Hi and welcome to this new section of the course, and in this section starts the real deal. So in this section we're going to develop the first application of the course. Until now you went through the basics of Python, you learned functions, loops, conditionals, and handling files, etc. And now we're going to practice all those concepts by actually building real programs that can be used by users, instead of just looping through trivial strings and numbers and so on. And so what are we going to build in this section? Well, you're going to build a program which you can give a word, an English word, and the program will return the definition of that word in English. So let me go ahead and demonstrate the program. I'm using Python 3. app1.py is a script. So the program asks you to enter a word which you want a definition for. For instance, let's say mountain. And so you get the definition for mountain, and in this case it happens to have two definitions. So a mountain is a feature of the Earth's surface that rises high above the base. And also mountain has another meaning, which is a great number of large amount of things not placed in a pile. Anyway, there are words who have only one meaning, like mathematics, I hope, yeah. So you get only one definition for mathematics. But also, the program has other features as well, such as, if you put rain with double N, so with an extra N, and press enter, the program, instead of crashing, it displays a message. It tells you, did you mean rain instead? So it's quite an intelligent program that guesses the word that the user may have had in mind when typing the word. So enter Y if yes, if you meant rain, or N if no. Oh yeah, I meant rain, so Y. And you get the definition for rain, which happens to have two definitions. This is the first one, this is the second one. The program also, if you enter a very random word that doesn't have any meaning like that, you get the message the word doesn't exist, please double check it, because the program cannot find a similar word to this. It cannot find a word first, and also it tries to find a similar word to this one, but it doesn't, because I don't think there's a match for this, and so it prints out this message. And there's also other things like if you have mix of letter cases there, like uppercase R and A, you still get the correct input there. So that's a program. It has a command line interface, which means you're passing the input through the command line and you're getting the input again from the command line. However, later in next sections, I'm going to explain you web applications, how to create web applications with Python, and so you then may get back here and actually create a web application using the code that you will be learning in this section. So you can extend this program to make it more user-friendly with a web interface where the users can enter the input through a web form, through a web page, and then press a button and then get the output on that web page. However, the code that you'll be learning in this section is very important. It's core Python, so you're going to learn about conditionals and loops. So you're going to implement all those that you learned in the previous section by developing this program. So I hope you like this, and I wish you success. See you in the next lecture. Hey, hi again! In the previous video I did a demonstration of the program so that you know how the program looks like and what is the output that the program generates, and also the interface of the program, which is a command line interface. So you input the data through the interface, the user inputs the data through the command line interface, and you get the output again from the command line. Now I have created a folder here somewhere, and I have give it a name. You can give it any name that you want, and inside this folder I'll be putting all the files of this project. So we're talking about the data files, like data.json. This is a file that contains the vocabulary where the program will extract, so we'll ask for a word, and this file has the definition of that word. And also the .py files will be put in here. So we know the output, now we need to figure out the way how to go to that output, and we will take the approach step by step, which means that first we're going to develop a simple version of the program, just like give the program a word and the program will return the definition of that word. But this will be very simple because, the user sometimes they may pass a word that doesn't exist, and as a programmer you need to count for that word, for that non-existing word. So instead of interrupting the program, showing an error to the user, you need to show a more user-friendly message to the user. And we'll do that in the next videos, but for now, the very first thing we need to think about is the data. So I did some research on the web and I found this dataset of words and definitions. Now this is around 5 megabytes of data, so in Atom it takes a while to open, so I clicked it and I'm still waiting for it to open. Now it opened. So if your Atom freezes, then you can open this with a more lightweight editor such as Notepad or Nano on Mac or Vim. So anyway, this is a .json file. So what is JSON? JSON is like a language. Some say it's not a language, it's just a set of rules how to format some data. So JSON follows this format. It starts with a curly bracket, and then all you have is pairs of keys and values. So this is like a Python dictionary. So the key is separated by the value by a colon. In this particular case, our values are inside square brackets, which suggests that sometimes you may have more than one item inside the brackets. For instance, let me search for the word Control F or Command F, rain. So that will take us in here. First, let me go to View and toggle Soft Wrap. So what that will do is it will fit the text inside my screen. So for the moment, you see precipitation is outside of the screen bounds. So look, this also takes a while because we have quite a lot of data here. Now the data looks better, so let me search for rain again, find. And so this is the key rain, or let's say the word rain, and this is the definition of the rain. And in this case we have two definitions because for some words you may have more than one meaning, or you have more than one form. For instance, this is the noun, rain as a noun, so it's a precipitation, and this is the verb for rain. So when it rains, to fall from the clouds in drops of water. So it's a verb and a noun, and they are separated by a comma. So this is just like a Python dictionary. And now we need to figure out how to load this data into Python. Because to access data from this file, you first need to load it into Python as a specific Python data type. And then you access data from that data type. So think for a moment what Python data type would be more appropriate for this JSON file. So think about that, and I'll show just that in the next lecture. See you there. So I believe it was quite easy to realize that the best way to load this data in Python is a Python dictionary. So this looks just like a Python dictionary, and once you will load it in a Python dictionary, then it becomes very easy to access a value for a key. So how do we load this into a Python dictionary? Well, let me open a command shell here. For now, I'm just going to demonstrate something quick in an interactive Python shell. But first you may need to close this JSON file because this is slowing down Atom. Don't save the changes, I didn't do any change anyway. So Python 3, that will open my Python 3.6.1. But anyway, even if you have Python 2, this program will work the same. So how do we load JSON into a Python dictionary? Well, for that we need to use the JSON standard library. With a standard library, it means that you don't need to install JSON, you just need to go ahead and import it. Once you do that, there is a nice JSON.load method there. And this load method, this expects, actually I can show it like this, help JSON.load. So this gets this argument here, which is a file-like object that contains a JSON document. So we're talking about the file object in Python, and we need to create that file. The way to do that is simple. So JSON again dot load. The way we create a file object is by using the open method. You know that already. And then you pass the path to the file. Now, since my terminal here is pointing to this folder, I just need to pass the file name. I don't need to pass any full path in there. So like that, you can either pass the R method, which stands for read mode, or you can just leave it like that, and the read mode is by default. Make sure to close brackets 2 times, so we have 2 opening brackets here, 2 closing brackets in here, and that's all. Now, what is data? Data is a dictionary, so it's a Python dictionary, and you can print it out. Yeah, it's quite a lot of data. So that took a while, but normally you'll not have to print out the entire dictionary. What you could check is to access a word and a key from the dictionary. Let's say the key rain, you need to use quotes for the key. This is what you get. So you get the value for the word rain, for the key rain. So now that you know how this works, more or less, try to come up with a function that gets as input a key and then returns the value for that particular key. And also try to incorporate the loading of the JSON file and also print out the output. So if you have issues with that, in the next video I'll show you how we do that. See you there. I hope you figured out how to create a function that gets a key, so a word, and it returns the definition of that word. So let me quickly build that program. Let me call this app1.py, import JSON, data equals to JSON.load, open data.json, that's it. And define the function translate. Let me call this translate word, and yeah, all you have to do is return data word. That's it. And then you can either let's say you can either do something like word equals to rain, or you can do this dynamically by asking for input from the user. Enter word like that, leave a space, and then all you have to do is print out the output of the dictionary, because you know this dictionary for now it just returns a string, but you are not printing any output. So if you want to show that output in the command line, you need to print out translate word, and that's it. Now, don't get confused with these variable names. This is a global variable, and this is also a global variable. So we define the variable here, and we pass it here. And then this, whatever is passed in here, goes to this one here. This could be a different word, a different variable name. So let's say W. So this is a local variable. It has a meaning inside the function. and it can be everything. So if you pass W here, it has to be W in here too. And this passes this value into this value in here. So usually programmers, they prefer to just enter the same name here and there. But for you as a beginner, I wanted to show you this difference, that this doesn't have to be the same with this. So save the script, maybe open another terminal, Python 3 app1.py, execute, enter a word, rain, and this is the output. How about this word? Oh, we got a nasty error there. But you don't want to show that to the user, right? Because this is not very readable. Trace back most recent call last. Okay. So how do we count for this scenario in our code? You need to figure that out. So think about it. In the next lecture, we'll do just that. So we need to take into consideration that word that the user passes may not be in the dictionary set of keys. So rain was a key of the data.json dictionary, but this name here was not, so we need to count for that. I'll show you that in the next lecture. See you. Alright, let's go ahead and make this program more user-friendly. So instead of showing this block of error, we're going to show a message that says the word doesn't exist, please double check it, or something like that. So the way to do it is, let me go to the Python interactive shell. You can check something like that, rain in data, and you get true. If you do this in data, you get false. So we need to make use of this and say if word in data, sorry, this has to be W, we're talking about this variable, and so if W in data, what you want to do is return the value. So this is the value, and so if this returns true, this is executed, right? Else return the word doesn't exist, please double check it. So when this is false, then else is executed. This actually the expression under else is executed, and this is not executed. As you see, this is quite readable, very human readable. This is the good, one of the great features of Python actually. And so I can save this now and go here, execute the program. Rain would work as before, and this says the word doesn't exist, please double check it. So as easy as that. So the program is taking shape. However, you need to do more tests to check for different inputs, in order to take into consideration every possible input that the user may put there. So let's say the user puts rain in uppercase letters, and this says the word doesn't exist, but actually rain is a word that exists in your data set. And so how do we count for different uppercase letters? You also may have like mixture of letters like that, and it still says the word doesn't exist. Or even rain like that, the word doesn't exist. So think about that again, and in the next lecture I'll implement that, which is very easy. See you there. Great, we have this program now that returns a value from a word that we put. So it returns the definition of that word, and it also counts for non-existing words in our dataset, which is data.json. To count for different cases of letters that the user may input, you may look at the dir str should show you the methods that you can apply to a string. And here is there's a lower method, and what that does, you know, is if you put rain there, it's so the method should be applied with brackets. You get rain, so the lowercase version of the letter. So since our data are all in lowercase in our data.json file, then what you do is, as soon as you get the input here, the string, you can convert it to lowercase, and then you pass that version to the dictionary access expression in here. So that would be something like, you know, w equals to w.lower. So we are updating the w value here, the string that the user inputs, and then the w here will be passed as lowercase. So as easy as that. Let me do a quick test. Rain, and you get the correct definition of rain. So let's think about more possible values that the user may input. Let me clear the command line so you see better. Let me call the program again. Weather works fine, but how about, instead of putting rain, the user types in an extra n there. The program says the word doesn't exist, which is true. But as a programmer, you want to make your program as more intelligent as you can. So in that case, you may want to consider checking for strings that are similar to what the user input. You know, rain, you need to check if there is some string that is similar to this word. And instead of saying the word doesn't exist, you want to suggest the user that, oh, well, maybe you meant this word, you know, similarly as you do a search on Google. So that's a bit complex, but not that much. And I'll show you how to implement that in the next lecture, step by step. So, see you there. Good. As I mentioned previously in the previous video, now we need to take into consideration when the user mistypes something. So instead of rain, they enter an extra n there or something like that. And in that case, you want to let the user know that they typed something wrong there. So how do we do that? Well, if you have no idea how to do that, the best practice is to actually do some research on Google. Because, you know, the world of programming is very wide, and you don't necessarily need to know every possible workaround or solution to do something. So basically we need to figure out an algorithm to compare, let's say, the word rain with double n and the actual word rain with one n at the end, and say that decide whether these are similar or not. But you don't have to reinvent the wheel if someone else has done it already. So that's why you need to do some research on the web and see if this is something that, if there is a library that exists there, or someone has a source code that does it, a function or something like that. But often you find a library for that. So if you do some research, you realize that you can do that using a few libraries, and one of them is a standard library, and it's called difflib. By the way, you can get a list of Python standard libraries in this page. So python.org, library index.html. This is the link. Here are all the standard libraries that you can import into Python. So let me go here and import difflib. So this is a library to compare text. And one of the methods is sequence matcher. It's a long name, so what you can do is say from difflib import sequence matcher. What that does is sequence matcher, you need to pass none there, None is the value for the argument is junk. So the first argument is an argument called is junk, which means that, if you're comparing two blocks of text, in this case we're just comparing words. So if you're comparing two blocks of text and you have some junk there, you have like break lines and spaces, then you need to pass here a function that ignores those lines. We don't have that scenario for now, so let's keep it simple. We pass null there for that argument, and then you pass it to strings. So you want to compare the word rain with a double N against the actual word rain, and that will return a sequence matcher object, which is nothing interesting. So you need to apply the ratio method to that to get the actual ratio. So this indicates a similarity between these two strings in a scale from 0 to 1. So they say that these are quite similar. Now this is about getting the similarity between two strings, but what we need instead is basically we have a list, a sequence of strings. So we have these keys of dictionary. We have a dictionary with lots of keys, and the user passes a word, let's say rain with double N, and you need to compare that word with all those keys of that dictionary, because you cannot compare rain with double N with rain with one N in your program, because you don't know that this is actually similar to this. So it's the reverse problem, so to say. But difflib has another feature for that, and it's called get close matches, like that. So you need to import that from difflib, import get close matches, but I'll consume this feature in the next lecture. See you there. So we looked at the sequence matcher class, which returns the ratio method of this class. It returns this number, but now we need to see how to get the most similar word out of a list, or out of the keys of a dictionary. So let's focus first on a list, on a sequence. So a list is a sequence, and from difflib import get close matches. Now if you do help get close matches, you can see the arguments that you can pass to this method. So the first one is the word. So that will be the word that the user passes, and then you have a sequence of possibilities. And so word is a sequence for which close matches are desired, typically a string. So typically this will be a string that you want to compare. And possibilities is a list of sequences, or a list of strings, you can say. So typically it's a list of strings. And then you have n equals to 3. That will define the number of the matches that you want the get close matches method to return. Let's say you pass a list of possibilities with 6 items, and each item has that ratio, so from 1 to 0, from 0 to 1, and this method will return the 3 most similar matches, the most similar strings to the word passed in here. You can change that argument value if you want, and you have a cutoff. So that's the ratio here. By default, this will return only those items that have a ratio of at least 0.6 or greater than that. So under that, the matches will be not included. Q to end the help, and get, let me try, close matches. Let's see what we get. Let's say rain, and then you have a list in square brackets, of course. Let's say help, pyramids, and rain. And I'll leave the n and the cutoff as they are by default. And so In this case, you get rain. The reason you get rain is because rain had a cutoff of greater than 0.6 or similar to that. If you're interested about the cutoff, you can use a sequence matcher, but we're not interested in that, in the specific value. So rain was the only one who satisfied those conditions. So we get rain here as a list. So, okay, we are able to get a close match out of a list, but how do we get the close match out of our dictionary keys? Well, we still have a data variable here, which I loaded previously here in this session. I loaded from the JSON file. So with data dot keys, so there's a method of dictionaries which is called keys, and with that you can get a list of all the keys of the dictionary. So we're talking about only the keys, not the values of the keys. So these are the words, and each of them has a value associated with it. And basically you can check the type of data.keys just to see what it is. So it's like a dict keys object, but it behaves like a list. And what you could do then is apply the get matches method. So you pass rain there to data.keys. Let's see what we get. So we got 3 matches. We got rain, train, and rainy. If you pass an n of 5, you get more matches there. But it's important to note that the list here is ordered. So the very first word is the one with a higher ratio of similarity. So we are only interested in that first word. How to get that? Well, you can ignore this number since you only want the first word, and you can pass 0 there because this is a list and the first item has an index of 0. So you get rain for the rainen mistyped word. So yeah, basically we have the engine to get the most similar word out of a sequence now. And all we have to do is to implement that functionality in our function in here. So first I would just like to let the user know through a message that they have input a wrong word. So I just want to let the user know so that they can run the program again, so next time they input a new word. For now, but later we'll do something more intelligent. So for now, just think about this. Give out a message where you mention your suggestion with the correct word that the user may have had in mind. So let's do that in the next lecture. See you. Great, the program is going well. I hope you're enjoying this. It's not a big program, so we don't have lots of code here, but however, this implements quite a lot of aspects of Python. So we're loading data in Python into a Python data type, and we have functions, we have conditionals here, we have user input, and later on we're also going to implement for loops in this code. So we'll talk about that later, why we need for loops. And so we have libraries, we are importing libraries here. And so this is JSON. We also need to import the difflib library, which we are currently working on. So let's focus on difflib for now. And what we have is, we pass this rain string with double N here. And we got a set of suggestions. So the best matches of the word rain out of the keys of our dictionary. But the user may also pass a word that doesn't exist at all and it doesn't have any similar matches there like that. So basically you have 3 scenarios. The user enters the exact word like rain and immediately you return data so with that particular key. That's the first scenario. The second scenario is when the user enters a word that is very close to one of the words you have in your dictionary, so like rain with an extra N. In that case, you want to return the first item of the list that the getCloseMatches generates. And the third scenario is when you get an empty list, which means that there is no such word or similar to that in your list. And so we have three scenarios, which means we need to sort of apply three conditionals in the conditional block here. At the moment we have only two, so we need one more which says, did you mean this word? So please double check it. For now we we'll just pass a message, and also note something. You may also want to pass a higher cutoff value there, like 0.8, because sometimes if this is a low like 0.5 and you pass like some random word, that will suggest you a few words which maybe you don't want. So you may want to play around with that. In that case you get an empty list. I think I'll use a 0.8 value for the cutoff when I implement it in the script here. So let's go to our code. The first thing we need to check is if the word is in data and return the value for that word. You may ask, what if you want to check for similarities first and not this? Well, I think the first conditional you need to apply is the one that you think will have more occurrences. So if you think that most of the users will enter the correct word, then you need to check for that conditional first. You don't want the program to go through the conditionals that have less probability to happen. So you first want to go through this, and then the others are ignored if this returns to true. If this doesn't return to true, if it's false, then you want to check for another conditional. And when you check for more than two conditionals, you need to implement the elif statement. So for multiple conditionals. And so we need to we need to check whether this list is empty or not. So if it's not empty, that means we got a match in the dictionary. In that case, we want to suggest that match. We want to mention that match in the message. So which means that if let me import it first. From difflib import getCloseMatches. So if elif getCloseMatches with the word given in data.keys, like that. So this is a list object, right? That's the same thing as this one here. So this is a list object, and you want to check whether the length of that list is greater than 0. If it is, you want to return a message. Let's say, did you mean? We use a string formatter here, %s. I'll explain what that is. Instead, did you mean that instead? And after the string, after you have closed quotes, you use the % operator, and here you pass a variable that will replace this formatter inside this string. So this will be replaced with whatever variable you pass all the right to this here. In our case, we want to pass getCloseMatches for w and data.keys, and you want to get the first element of that list and put it here. So this is to understand it. Let's say we have a variable which has a value of 1, and you say, hey, s, like that, %a, and the %s will be replaced with 1. That's the same what we're doing in here. And yeah, that's all we have to do else. So if this evaluates to false and this evaluates to false as well, then what that means is we're dealing with an empty list. So the user entered a word that didn't have any match in our dictionary and didn't have any similar word in our dictionary. So you want to return the word doesn't exist. Let me save the script. Go to the terminal, the upper arrow key to call a previously executed command. So Python 3 app1.py execute enter word. Let me start with a correct word, rain, and you get the definitions for rain. Let me execute again, rain with an extra n. And yeah, we get this message, did you mean rain instead? So the %s was replaced with the first item of the list returned by getClauseMatches. And again, if it has a very random string there, it says the word doesn't exist, please double check it. And yeah, that's it. However, I still see an issue with this, so we still can make the program more user-friendly. The problem now is that when the user enters like rain by mistake, what you say, you just pass a message there saying that, oh, did you mean rain instead? Oh, yes, I mean rain, but how can I enter rain? Why do I have to execute the program again? So I'm thinking of a solution where instead of just passing a message here and ending the program, instead of that, you execute another input statement. So another input statement, another input function like this one in here, where you ask the user to enter, let's say, y if they meant rain, or n for no, so y for yes, n for no, if they didn't mean rain. So if yes, then you basically pass. You return the value for the rain word. If they pass no to the input message, then you say sorry if that's not the word that you meant, then we don't know what you have in mind. So we say the word doesn't exist, please double check it. And that's what I'm thinking. And yeah, think about this, and I'm going to implement it in the next lecture. Talk to you there. Great, as I mentioned previously in the previous video, now we're going to implement an extra input, user input message into the program. So instead of passing, returning this string, basically what I want to return is an input message. So if the program finds out that the user passed a word that has a similar words in the dictionary, then you want to ask the user to enter y or n. So how do we do that? Well, with an input function, of course. Like that. So let's add another message after this. Enter y if yes, or n if no. So basically, whatever the user enters, you need to process that input. And that input, so y or n, they will be basically stored in a variable, but not yet. So in this configuration that we have here, nothing will be stored in the variable. It will just be a value on the fly. So you need to store this in a variable. Let's say yn, so for yes and no, equals to that. So now either y or n will be stored in yn variable, and you need to process that variable. So if yn equals to yes, what do we need to do? So if the user meant to say rain, then we return data. here we need to pass the correct word. The correct word, we get the correct word from this expression. So get close matches will give us the best match, and we need to pass that match into the data dictionary so we get the value of the definition for rain. Because so we use that match because the user agreed that the best match was rain. So we message this will be replaced by rain, and the user agreed for that. I hope this is clear. Please ask questions if this is complicated. I'll be happy to answer you. So if yes, then return this. Let me execute this intermediate step. Oh, sorry, I used the equal operator here, which is an assignment operator. So you need to check to use the comparison operator, which is constructed of two equal operators. Save the script again and go ahead. Enter word rain. Did you mean rain instead? Enter Y if yes or N if no. Let me enter Y. And yeah, we correctly get the definitions for rain. Great. Maybe I need to improve the message here, delete the dot, and use a colon there and a space. And that should be better. If you pass rain again, and if you pass yes or no, you just say N, you get none, because you are not taking into consideration the N string. So you get none because the function is not returning anything. You know what happened here is user passed rain in here. So word is equal to rain. Word is passed in here. So this Y is equal to rain. And then we check if rain in data is not in data because it's with 2n, right? So this is not executed. The function does not execute this statement. It doesn't return the definition for rain, but it goes to this statement. And this finds a similarity. So the list is greater than 0, and then it goes and executes this. So that's why we got this another input message here. And then we continue there. So we are indenting under elif. We have another nested conditional, which is no problem. But yeah, be careful, you need to indent it. So this is one level of indentation deeper than this one in here. And so here we are. If the user passed Y, we return this statement. If the user passes everything else, then you are not counting for that particular scenario. Therefore, there is no return statement executed, so the program will end here and it will return none because nothing was returned. This will also not be executed because this is one level of indentation with this one, and since this was executed, the program never goes to this level here. So what we need to do is we need to count for other user inputs such as n. In that case, if the user enters n, well, all we can do is return the message word doesn't exist. Please double check it, which is the same as this one in here. And we need to count for another condition. You know, the user may pass Y, may pass N, but they may also pass another random string, and you don't want the program to return none. You want the program to return a message such as we didn't understand your query. And that's it. That's all you can do. Or your entry. Maybe that's better. So this is a program. Again, we have a scenario where the user enters rain, exactly, and this will be executed in that case. And the scenario when the user enters a word which does not have any match. So A is D, like CA, 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 C, something like that. In that case, this will not be executed. And yeah, that's it. Let me test the program now. Enter word rain. We get the definitions for rain. Again, enter word rain, like that. Did you mean rain instead? Enter Y if yes, enter no if no. Let me try yes. And we get the definition correctly. And rain. Enter N for no. The word doesn't exist. Please double check it. Okay, that was good as well. So we got this executed. The other scenario would be like that. And instead of entering Y and N, you just type in something. And you say we didn't understand your entry. Good. And the other scenario is when you enter a word that does not have any match at all. And in that case, this will be executed immediately. And that's it. By the way, even if you enter numbers, let's say 1, the word doesn't exist because it's not included in the dictionary. And yeah, I think our program is quite smart now. It's considering lots of scenarios there, and yeah, it's quite user-friendly, I'd say. However, there is one last thing that we can improve, and that's the way that the program displays the definitions. So when you pass, let's say, tree also has two definitions. Let's pass a word that has one definition. Structure, maybe. Oh, this has 3 definitions. All right. Pyramid. This also has 2 definitions. Anyway, you get the idea. I was trying to get to find a word that has 1 definition, but basically what you get with such a word that has 1 definition is you still get a list which ends in here, so it doesn't have a comma and it doesn't have any other items, so it's a list with 1 item. And when you have a word that has more than 1 meaning, you get this list with more than 1 items. So you don't want to show the user a list with brackets like that. The best thing to do to show to the user is, if you have 1 meaning, 1 definition for the word, you just show this definition. No quotes, no square brackets, just the definition. And if you have more than 1 definition, you only show 1 definition per line. So basically you have like multiple lines with definitions. And yeah, we need to implement that too, to say finally that our program is good and can be used by anyone, and the output is easy to read. So think about that. We're going to implement it in the next lecture. See you. Great, we have a working program now, and we added every feature that we wanted. The only problem now with the program is that the output is not very user-friendly. With that I mean, let's say yes here. So this is the output, and you get a list here. So it's a Python list. And what we want to do instead is we want to show each of these lines in 1 separate line in the terminal, so that output will be more readable to the human eye. And let's go ahead and do that. So how can we implement such a thing? So this output now is a list object, which means that the call here, the function call, this produces this list object. And so what can we do is we could maybe iterate through this list object. Something like we can store the list object in a variable, so output will be assigned this list. And then what you can do is you can say for item in the list, in the output list, print out the item. Let's save this and try out. We're going to have an issue here, but 1 step at a time. Enter Y, yes, Y. And so this is what I wanted to have. So the first definition, precipitation in the form of liquid water, goes in the first line, and the second definition, to fall from the clouds in drops of water, goes to the second line. So that's good. However, we should keep in mind that our program does not produce only the list, but sometimes it produces strings as well. So such as this one in here. No, I didn't mean that. Anyway, so this is what you get, and you don't want that. This is a message saying that the word doesn't exist. So what the program is doing, what Python is doing, is it is iterating through every type of output that the function generates. So our function generates a list sometimes, and sometimes it generates a string. How can we fix that? So we have a list and a string. Let's think of a difference. How can we discriminate a list from a string? What's the difference between a list and a string? Well, the difference is clearly a data type. A list is a list object, and a string is a string object. So how about implementing a conditional here, which says something like this: if type of output is a list, then indent this with 4 spaces, and that one as well. So this loop now is nested inside the conditional and will be executed only when this evaluates to true. So only when we have when we get returned a list from the program. So else, if it's not a list, it has to be a string. So in that case, we want to print out the output without iterating through it. So let me check. And we get the output correctly this time. The message, the word doesn't exist. Please double check it. Let's check another time with a correct word, and we get the correct definitions in there. Let's try another word, mathematics. And this time the mathematics word has only one definition, so we get the definition printed out in here. So it's a science. Let's try the other scenario as well, rain. Did you mean array instead? No. The word doesn't exist, please double check it. So we got this line here executed. So yeah, this is the complete code. And I think we can consider our program complete now. So that's what I thought of adding to the program. Now the program is quite user-friendly, and we are considering many scenarios there that the user may input to the program. However, the interface is still a command line interface, so it's not a desktop graphical program, and it's not a web application. The interface is the command line, so you send input through the command line and you get output through the command line. And what I'm trying to say is that you can actually extend this program so that you can transform it into a web application, where the user, instead of entering the input through the command line, they can enter input through a web page. So through a live website, they can enter input, push a button, and then get the output dynamically on the HTML web page. So that is possible with Python, but you're still not ready to do that because we have quite a few more sections to go. We have some applications where I'll teach you how to develop web applications with Python. And after that, you can go back to this code and extend it and create a web interface. And also you'll be able to create a desktop graphical user interface with the knowledge that you'll gain through these sections, because we're also covering graphical user interfaces in the course. And also we are also covering databases. So why I'm mentioning databases? Well, because in this program we're using this file where to store our dataset. The problem with this is that if this gets too big, for now this is just 5 megabytes, oh that's good, but if the file gets too big, then you need to load the file in Python every time you execute the script. Like here, we are loading the file into the Python session when you execute the script. Now, if the file is too big, that will be very costly in terms of time. So what you want to do instead, you want to use a database, maybe. With a database, what happens is that you make a query to the database, and instead of getting the entire dataset, you actually get only that row or that value which you queried for. So databases are very efficient. I will cover databases later in the course. And so after a few sections, I'll get back to this program. I'll give it to you as an exercise so that you can extend it by creating an interface, a graphical interface for that, or a web interface. And also I'll give you access to a database where you can query data for this program so that it becomes a real robust with a very friendly user interface. So I hope you like the idea, and I hope you are enjoying the course. And yeah, let's move on with some more sections. I'll see you later. Bye. Hey, welcome to this new section. And in this section, you will learn how to use pandas, which is a very important Python library, and you really don't want to miss that. So what is pandas? Well, pandas is a library providing data structures and data analysis tools within Python. Or if the word tools confuses you, then you can say pandas is a library providing data structures and data analysis code. So basically, pandas allows you to load data from different sources into Python and then use Python code to analyze those data and produce results, which can be in the form of tables, text, and also visualization with the help of visualization libraries such as Bokeh. Bokeh, which is covered later in the course. So for now, we'll focus on data without visualizing them, and pandas is great for that. So practically, how do we use pandas? Well, you learn how to open text files using Python built-in file handling methods earlier in the course. Now, what we opened from text files was just plain text. But what if you want to load text files with data constructed of rows and columns? So things get a bit complicated. But here is where pandas comes into play. So you can probably do that using built-in Python methods that we have learned in the course. But to be more efficient, and to be much more efficient, you need to have a high-level library such as pandas, which is able to recognize such data structures automatically. So I use pandas for loading data from data mining activities such as web scraping. So you scrap data from a website with Python and then store those data in pandas data frames. So you use pandas to provide data structures for you in Python. And I use pandas for loading data from Excel files, and also use pandas for analyzing those data instead of using Excel. Excel can be good for analyzing a small table of data that fits in your screen, in your computer screen, but for data larger than that, you really want to use code. So you write Python code once and then you reuse it with other data as well. And you don't want to do selections and dragging and many other cumbersome operations that you normally do in a graphical based program such as Excel. So code is the way to go if you want to be efficient with data, and Python is great for that with pandas. So you really want to get a good hang of pandas, and you will learn that in this section and also practice it with real-world applications that we'll be building as you progress through the course. Now that's enough with words, let's go ahead and install pandas. And you want to open the terminal, and the process is straightforward. You say pip install pandas. Now I mentioned that pandas is a high-level library, and pandas is based on NumPy, which you can see in here. So pandas is now trying to install NumPy, because without NumPy you cannot use pandas. And NumPy is a more low-level library than pandas. We'll cover NumPy later on, but I wanted you to know pandas first, because that is more easy to understand. So once you know how to use pandas, then we think about NumPy, and I show you how NumPy is based off pandas. So let's not think about NumPy now. And yeah, this was successful, but if for any reason it wasn't successful on your side, and I know that in some Windows distributions you may get an error such as this one here, so it says unable to find this bat file, and that happens because Pandas is trying to compile itself, but it cannot find a compiler. So in that case, the easiest solution that you can do is to use precompiled Python libraries, which you can find in this case in this website. So they are provided by Christoph Goelke. And yeah, you want to locate NumPy first. So here is NumPy. You click that and that goes down here. And then you want to pick up your version. So if you have Python 3.5, you'd want to go for this CP35, and then you have 32 bits of Windows and 64. So you want to pick your own bits. And so what you do is you download that, and that is a wheel file, which is the same file that you install with pip, but with pip you download it and then you install it. In this case, the download is being done manually, and then we point to this file with pip again to install it. I'll show you how to do that. And yeah, once that file is downloaded successfully, I've put it in here in my C drive, CPP, and then you want to either cd to that directory, and then use pip install, and then start typing the name of that file, and tab to get the complete file name. And yeah, now you should press enter, and that will install NumPy for you. Once you're done with NumPy, then you go ahead and get Pandas as well. Pandas, yeah, these are the distributions. Again, you get 3.5 if you have the 3.5 version for Python, and the Windows version as well, and you repeat the same process. And yeah, I hope that is clear. Once you install Pandas, then you can simply go ahead, import it, and if there's no error, then you're good to go. So that was about an introduction to Pandas and how to install it. Let's go ahead and dive into some code now in the next lectures. See you. Great. Again, Pandas is a library that provides data structures and data analysis tools in Python. So in this lecture, you'll see what I mean with data structures and data analysis. So you'll see the main Pandas object, which is a structure that contains the data. And you'll see that how we get data from this structure and analyze them. So I'll open a simple command line, and for now we'll use IPython, which is great for data analysis and working with data. But even better is Jupyter Notebook. Jupyter Notebook is like a Python shell. It's actually a combination of a Python shell and a Python editor, and it's a browser-based tool where you can write Python code, and it's very efficient, so it really boosts your productivity. But for this lecture, I want to start with simple things, so one step at a time, and I'll introduce you to Pandas using IPython only. And then in the next lecture, I'll show you how to set up a Jupyter Notebook, previously known as the IPython Notebook. So you'll set up Jupyter, and I'll show you how to work with Jupyter. So for now, let's go ahead and use the plain IPython console. Import Pandas. And yeah, normally the first thing you do is you want to import some data, let's say from a CSV file or from a text file, or even an Excel file or JSON or other formats, which we'll be covering later. But there are also other ways to create a Pandas data structure. And now the first thing you should know is that this data structure that I'm talking about is called a data frame. So that's a spatial object that will hold the data. And you can create one. You can store a data frame in a variable, let's say df1, pandas data frame. So I'm creating a data frame manually, passing values manually via Python. Normally you want to use other files, like I mentioned. So data frame, and And now think of the data frame as a table. So you may want to pass a list of lists, where each list will be a row of that table. So let's pass some data there. 2, 4, 6, and 10, 20, 30. You execute that, and that was successful because you didn't get an error. df1, and here is the data frame. So 2, 4, 6 is the first row, 10, 20, 30 is the second row. And these 0, 1, 2 are the names of the columns. And these are referred as indexes. So 0, 1 here are indexes for the rows, and these here are the column names. The beauty of pandas is that you can also have your own column names if you like. So I'm gonna call this expression again, and I want to pass here a parameter called columns, and that expects a list of names, which has to have the same number of items with the number of columns that your data frame has. So if you pass list with 3 items, you want to pass 3 columns here as well. Let's say price, something random, age, and value. You execute that, and let me expand this, df1, and this time you see that you have your own column names there. Now similarly, you can pass custom names for the indexes as well, by passing index as parameter, and then you'd want to pass a list with 2 items because we have 2 rows only. Let's say first, second, df1, and you have custom indexes. However, normally you won't have to pass custom indexes. Data normally have a defined number of columns, but the rows, you may have hundreds and thousands of rows or millions there. So you really don't want to mess up with index names. However, the feature is just that, in special cases. So there's one way to create a pandas data frame, and you also have other ways as well, which are not very common to use, but I just wanted to know that they are there. So again, you pass a list here, and then what you could do is you could pass 2 dictionaries inside that list. So you can see the similarity. Here we used a list of lists. Here we are also passing a list object, but it's a list of dictionaries. And yeah, what you could do here is you could pass values, keys and values for the dictionary, and here as well. So let's say name John, name Jack. Execute that, df2, and yeah, this is yet another data frame. If you wanted to have more columns there, such as surname, you'd want to add here another key and value for the dictionary. So something like surname, and now if you execute that and df2, you'll get the surname column added there. But for Jack you get none because you didn't pass a surname in the dictionary, in the second dictionary. So if you do the same for Jack, if you pass a surname, you'll get the value in here. So those are 2 basic ways to build data frames on the fly. And as I said, normally these values will come out of files, of CSV files, Excel files, etc. I will do that throughout the next lectures. And one more thing I want you to know is, so this is a data structure, and now what data analysis means is, out of this data structure you want to get out information. So you may want to extract, for instance, the average of all these values. So 2, 4, 6, 10, 20, 30. So here we enter the phase of data analysis. And the approach to do that is, this data frame object now, which you can see the type df1. So it's a data frame of pandas. Now this data frame object has methods attached to it. If you do dir, and yeah, you see that it has quite a lot of methods that you can apply to it. Let's locate the mean method there. Here is mean. So what you could do is you point to df1 and then mean and brackets, and you get the mean of all the columns. And if you want the mean of the entire data frame, you could apply again the mean method after that. So what this does is it applies the mean method over this series here. So this type is a pandas series object. Series have more or less the same methods that you can apply to a data frame. So df1 and df1.price, and you get the series of the price column. So that is also, if you check the type, that is also a pandas series. So a data frame is made of series. And of course you can apply the mean method to price as well. And similarly you can apply other methods as well that are available there. So max, and you get the maximum value. And yeah, that's about the introduction to pandas. In the next lecture you will learn about Jupyter. It's very pleasant to work with Jupyter, so don't miss that. And then we'll go ahead and open data frames, create data frames out of files. So I'll see you later. Well, in this lecture I'll show you how to set up the Jupyter Notebook, or Jupyter for short, and also how to use it. So far you've worked both with a Python or an IPython interactive shell, but also you've worked with an editor such as Atom. Sometimes you may have the need for a hybrid between an interactive shell and an editor, when you want to test things out, but you also want to save your blocks of code that you're writing. Because an interactive shell is great for testing things quickly, but you can save the code, and the editor is good for saving the code, but it's not great for testing things. But I can tell you that such a hybrid tool exists, and that is called Jupyter Notebook. And that is an amazing tool that will boost your productivity. And Jupyter is especially good when you're working with data, as it's a great environment to explore data, and you'll see its usefulness in just a bit. Of course, you still want to use editors such as Atom when you're working with multiple Python scripts that interact with each other. That's the case of web application, for example. When you're developing web applications, you'll have to deal with multiple Python scripts and also HTML files, CSS, and other files as well. We'll build a web application later in the course, and you'll see how Atom is good for that. But for data, use Jupyter. So Jupyter, let's see how to install it. Well, you can go to the installation, so install, and you can go through these instructions. But instead of going through this, I would advise you actually to use your command line to install Jupyter, and typing pip install Jupyter. So that will download Jupyter and it will install it in your system. And then to start a Jupyter session, a good practice is to go to a folder, let's say test3, and here you can open a command prompt, and then you type Jupyter Notebook, and that will open a Jupyter session in the browser. So the Jupyter Notebook is actually a browser notebook. The reason I opened the Jupyter Notebook in the command line was that at least on Windows, when you do Shift and then right click on a folder, your command prompt is opened in the current folder, so in this one here. And then when you create a notebook file now, every file will be saved in this directory here. Alternatively, you can open your command prompt everywhere you want, and then you can cd to the folder where you want to save your Jupyter notebooks. Alright, now we don't have anything here, so what you can do is create a notebook. And we install Jupyter as a Python library, so under notebooks we have Python 3 available. So the kernel will be Python 3. If you have associated other languages here, you'll see them under here, under notebooks. So this is an empty notebook. And this is the name of the notebook, and you can change this to, let's say, testing. Press OK. And if you go to the folder, you'll see that a file with testing name and IPython notebook extension was created. So that is created automatically every time you type something here, you do some changes or something. Now let me show you how you can work with the IPython notebook. So you can consider every cell, this is a cell, and you can consider every cell as a line in a normal Python shell. But here in this shell you can actually write multiple lines of code. Let's say print 1, and then if you don't want to execute this right away, you can press enter. So with enter you enter a new line in the cell, and then print 2, and so on. And if you want to execute the cell now, you can press Ctrl enter, and you get the output. Now if you want to create a new cell, Alt enter would do that. And here you can write another block of code. With enter you go to the next line, and so on. And if you want to go to the next cell right away, so before we pressed Ctrl enter, now you can press Shift enter and you go to the next cell automatically. And with Shift enter you also execute the cell where you were working on. You can create new cells with Alt enter, and you can delete them by pressing, first you press escape and then you press DD 2 times. DD again. So it's quite flexible. Something you should notice is that we have two modes basically. We have the command mode. So when you are in the command mode, you see a gray rectangle around the cell. And when you are to go to the edit mode, then you press enter. So while you are focused on the current cell, you press enter and then you edit the cell. So in edit mode, when you type things, you're inserting text in the cell, you're inserting code in the cell. Escape and command mode, DD, and you delete the cell. Alt enter and you enter a new cell. So these are the most used shortcuts, keyboard shortcuts. But if you want to know more shortcuts, you can go to help and then keyboard shortcuts, and then you see a list here. But these are good to get started. When you're done with this, you can just close a tab, and you can also close the directory tree here. So notice that Jupyter actually opens in a localhost session. And if you want to open again your notebook, so you can go here again and go to open command window here and Jupyter notebook. And here is the file, and it's just as we left it. Now a Jupyter notebook is best used for doing explorations, and especially data explorations. So if you're working, let's say, with data analysis or data visualizations, the Jupyter notebook is perfect to use. You can use the Jupyter notebook, for example, to load a table of data in the session. And for that you'd use pandas. So you import the library, you press enter or shift enter to go to the next cell, and you press enter again to write something. So let's say df equals to pandas.read CSV, and I have a CSV file somewhere in my system. Press enter and whoa. So you get a nice HTML table which was loaded from the CSV file, and you can also plot graphs in the Jupyter notebook. So that's also something you're learning in the course. And so data analysis and visualizations, you can also use the Jupyter notebook for web scraping. And that is very convenient because you have these blocks of code, and then you have to continuously tweak the code. So you may want to change something here, and then you get a nice display. Not this one exactly, because this is a messed up string, but this one For instance, you have a slider here, so you can scroll up and down inside a separate window that doesn't affect your general your main window. So I hope you've gotten a good idea of the Jupyter Notebook. Just take a note of the shortcuts, of the keyboard shortcuts to execute code, the edit and the command mode, enter, escape, and enter again, and so on and so forth. And you just practice them a little bit, and you'll get used with Jupyter very quickly. See you in the next lecture. Great, now that you have a basic understanding of pandas and you know how to use Jupyter Notebooks, we can go ahead and learn how to load various kinds of files in Python using pandas and Jupyter. So I've got 5 files here. They contain exactly the same dataset, and this is a text version, or let me open the Excel version that will show a pretty overview of the data, as you can see. So we've got 7 lines of code, including the header, and we have also 7 columns. So it's just some basic data of supermarkets, so the address, city, state, country, and the name of the supermarket and number of employees. And similarly, we have exactly the same data, but in different formats. So we have CSV, and CSV means comma separated values. So it's basically a text file where the values, the columns, are separated by commas, as you can see here. So every column is separated by a comma, but it has a CSV extension and it can be opened with Excel. So if I open this now, you'll see the same data set that you saw in the XLS file. We also have the same data in separated by semicolons, as you can see in here. And yeah, if you're working with data, you're probably familiar with these kinds of files. So this is how to store data. You need to have some conventions, and using such convention, then you use other programs such as Python to load these data. So when you load a CSV file, Python knows that the values will be separated by commas, and it knows how to separate them. It knows how to extract values. So we'll open all these one by one. We also have a JSON file, which is yet another format to store data, and looks like a Python dictionary actually. So we'll learn how to convert them to a pandas data frame as well. So all these will be converted to pandas data frames. And yeah, I'll go ahead and start Jupyter Notebook. Here are my files. I'll go ahead and create a new Jupyter Notebook for Python 3. Before I go ahead and load those files in Python, there's a trick I do usually. I import OS and then os.list there, and Alt Enter, execute that. So you go to the next line, and what you get is you get a list of files and folders as well, of file names that you have in the current directory. So now I don't have to switch to my folder to look at the names. I have everything in here. Now I can go ahead and import pandas. And let's start loading these files one by one. Let's say df1, so data frame 1, and that would be equal to pandas.read CSV. And then you have to pass the name of the file that you want to open, supermarkets.csv, and just enter. And maybe you want to print that out, so df there. And we got an error. Let's see why. It says supermarkets does not exist. Yeah, I forgot an R here, just there, and this time it worked. So dd to delete that cell. And yeah, what we got here is, so we loaded the data frame first, and then we printed that out, so that we got this table, nice table in there. That's how easy it is to load data from CSV file. Now, if you see this, this is in bold, this first row there. And that's a special row, so that's the header of your data frame. And Python Pandas was able to automatically recognize the header from your file. So this method, the readCSV method, has a header parameter, and that is set to true by default. But if you want, you can set it to none. And that's how you tell Python that my data don't have a header. So what Python will do is it will treat your first row of your file as a simple row. So it will just dump it amongst the other rows. And what it will do, it will create a default header for your data frame with numbers. So I'm going to remove this and leave it as it was. Notice that we also have an ID column there, which if you want, you can use it as an index for your data. So if you want to use ID as an index instead of letting Python define your index, what you do is you apply the setIndex method to your data frame, and then you say ID there, execute, and what Python will do, it will search for the column with name ID and it will set it as an index. df.1 shape, if you want to know the shape of your data frame, so you get 6, 7, meaning that you got 6 rows and 7 columns, including the ID column. And yeah, that's how you load CSV files. Now let's go ahead and load df2 pandas. What's next? Well, next is JSON. So instead of doing read CSV, you want to do read JSON. And then you just pass the name of your JSON file, including the extension, of course. I executed that, I forgot to print that out. So this is the JSON file, and similarly, if you want, you can set the index to ID and execute again, and ID is set as an index. Now you can also notice that the order of the columns is not the same as the previous CSV file that we opened, which is not a problem. Every column has its own name, its own identity, so having columns without an order is not a problem. And let's go ahead and load the XLS file, XLSX actually, an Excel file. So pandas read Excel, and you pass the name of the Excel file. And normally you should also pass another parameter here for Excel files, because you know Excel files might have multiple sheets inside them. So you want to specify the sheet name, which starts from 0, so you need to pass the index actually. If you want the first sheet, you want to pass 0. If you want the second sheet, you want to pass 1, and so on. So I'll pass 0 there. I had only one sheet in the Excel file. df3 execute, and yeah, we were able to successfully read the Excel file as well. Yeah, let's move on with the txt file. So it's supermarkets separated by commas. So it's a data structure separated by commas. For that, so for txt file separated by commas, again you use readCSV. Just like that, df4, and here is the data frame. So this supermarkets.csv, actually some say it's a comma separated file, but to be more accurate, you would say a character separated values. So C is for character, and yeah, there might be different characters there. In this case, when you have commas as separators, you don't have to pass any separator parameter here. But when you have other values as separators, you will have to pass that. That is the next scenario. So df5 pandas.read CSV. So we're talking about supermarkets semicolons. Supermarkets semicolons .txt. And yeah, let me try this as it is now. So if I execute that, Python will not be able to recognize the semicolon there. The reason to that is because the separator parameter has a value of comma by default. So you want to change that to your separator, which is a semicolon in this case. Execute. We got an error there, unexpected keyword argument separator. So it seems like read underscore CSV doesn't have a separator parameter. In that case, you want to ask for help. And yeah, here is the parameters that you want to pass. So it's actually a sep, and you can see that the default value of sep is a comma. So close that and go here, change that to sep, execute, and here is the data frame. Great. What's left to do? We consumed everything, and that's about reading local files. Now, Pandas also allows you to read online files directly from the web. For instance, here we have a CSV file in this website. So I browsed to that, and then it was downloaded. And if you want, you can go ahead and put that in your Jupyter folder and then open it as we did. Or you can grab this URL, go here, say df6.read CSV, and then pass the URL just there. df6 to print that out. And boom, here is the file. So it's the same, exactly the same CSV file that we opened earlier up, but we were able to get it from the web. And yeah, similarly, you can get other files as well, JSON. You can pass it as URL. Just there, and print that out. And here is the file. So this can be very useful when you want to automate things. Let's say you have some data from a website, from a data provider. Or maybe you have multiple files and you want to write a loop in Python that accesses these URLs, and then it gets the data, and also you then analyze the data and so on. So yeah, that's about loading data in Python via Pandas and using Jupyter. So I believe you find this very easy. And yeah, we'll move on and do some data analysis in the next lectures. So I'll see you there. Alright, now that you know how to load data in Python via Pandas, and you know how to do that using different data sources, so CSV, JSON, text files, and Excel, and now you want to understand how and learn how to manipulate these data frames. And by manipulation, what I mean is deleting rows and columns from your data frame, and adding new rows and columns, and also modifying existing rows and columns. So that's what you're going to learn throughout these lectures. But first of all, I would like you to understand how data frames are indexed. And with indexing, I mean, we have this data frame here, and this can be a big one. So this happens to be a shorter one with only 6 rows. But if you have big data frames with lots of columns and rows, then you may want to extract information out of that data frame. And to extract information, you need to have like a coordinate system in that data frame, like an embedded coordinate system. So that if you want to access, let's say, from here and 15.2, and then maybe this other portion, so these 2 rows here, this portion in here, you want to know how to do that. So that's what you're going to learn now, how data frames are indexed and how you can slice them. So let's try to extract that portion of the data frame. Let me create some empty lines here. I don't want to confuse you with that data frame, so we're working on this one. And yeah, df7. And what you want to apply now, there might be different ways to access that portion of the data frame. The first way is to use label-based indexing. The other way is to use position-based indexing. So your data frame has column labels and index labels. So these 1, 0, 1, 2, 3, 4, 5 are index labels, and these are column labels. Now these, the index label, in our case, it's a bit confusing because normally it can be text, such as, let's say in our data frame, the address is a unique column which you can use as an identifier. So if you want, you can set that as an index. Address, execute, and now you see that this is in bold. So the first column is in bold, meaning that this is the index column of your data frame. So now you can use labels from your index column and labels from your header, your column names, to access portions of your data frame. Just be careful though, because with this operation that we just did here, you know, if you print df7 now, df7, you'll see that you still have the old index column in there, so 0, 1, 2, 3, 5. The reason to that is this set index method, as many other methods in pandas, is not an in-place operator, meaning that all this will do, it will spit out an updated data frame, but it will not store that data frame in your variable. So the variable, the data frame, remains the same. It just prints out a new data frame on the fly, just for printing purposes. So what you want to do to store that is you create a variable, which can be the same variable as this if you just want to update your variable, but it can also be another variable like df8. I'll just want to update the existing variable like that, and that will not print out any output, so you want to do that manually like this. So now when you print df7, you see that df7 is updated with this address column as an index of the data frame. So be careful with in-place operations. You know, you can see that df.set index, a question mark to ask for help. Oh, sorry, it should be df7 set index, and you can see that you have this in-place parameter there that is set to false by default. So which means you can also pass in place after this and set it to true, and that will update the existing data frame without the need to save the data frame to a new variable. But I would recommend that you know, just get used to creating new variables when you apply methods to your existing variables, existing data frames, and you should be good to go. Delete that, and yeah, let's get back to our original purpose now, which was to slice this portion of the data frame. I will first do it using label indexing. With label indexing, you want to use a lock in there, so the lock method. And then you pass square brackets in there, and then that gets two elements. And the first element could be a range of the index column. So we're talking about labels, about strings, so you'll have to pass, you know, 735 Dolores st, and then a range, so with a column there, 332 heal st, and then from country to id. Execute that, and yeah, this is our portion. So when you use labels, you're including the first label that you pass there and the last one as well. So everything between those. And like here, country and employees is included as well, but ID also. And of course, similarly, almost similarly, you can access, you know, single cells from your data frame, just like that. So the intersection between this index label and this column name is USA, which should be this one here. If you want all the USAs, then you just pass everything there and you get everything here. Which of course, if you want, you can convert it to a list. So a simple list using the Python built-in function, which is list. And that's about label-based indexing. Now, this is not the common way to extract data from the data frame. More common could be to access data based on indexing, not based on labels. So to do that, you do df7, and instead of lock, you do ilock. that again expects 2 items. So the first would be the range of your indexes. Actually, let me print out the data frame here so that you can refer to that. So let me access from Dolores to 23rd Street. That would be 1, 2, 3, I believe, yeah. And also from country to ID. So again, 1, 2, 3. And yeah, you can see the difference now. You know, the ID wasn't included there, and either was 23rd Street, because this is, as you do with list, this is upper bound exclusive. So with Python list, 3 is not included in the slice. But with labels, that the last item of the range was included in the slice. So in this case, you want to pass 4 there and 4 there, and that's how you get your portion. And of course, similarly, you can do things like that. So you get all the rows or only one of them. So that would be a row with index 3, which is this one, but only 4 columns: country, employees, and ID. So USA 10 and 4. All right, that is position-based indexing. Now we have one more very useful kind of indexing, and that is combined indexing. So in certain scenarios, you might need to access a portion of rows without having to pass names for the rows. So you want to access rows based on indexing, based on their position. But on the other hand, you don't want to access columns based on positions. You want to access like a certain column, so which name you know about. So you don't want to count the column. And here comes in handy the IX method. So that allows you to enter a combination of indexes and labels. So that will return you the row with index 3 and the column with the label name. So you get Ben's shop. And you cannot do this neither with iLock nor with lock. That's why IX exists there. And of course you can put 2 positions if you like. So name would be 0, 1, 2, 3, 4, and you get the same output, Ben's shop. Which brings us to the point that if you want, you can always use IX and forget about iLock and lock. But IX is not recommended over iLock and lock. So these are more explicit, and they will avoid errors sometimes when you do position-based indexing. So I also suggest you use iLock and lock whenever you can, and then switch to IX when you want to do these kinds of combinations between labels and positions. And yeah, that's what I wanted to teach you about data frame indexing and slicing. And I'll talk to you in the next lecture, where you'll be learning how to delete columns and rows from a data frame. See you there. Alright, now you know how to extract portion of a data frame, but how about deleting columns or rows from a data frame? Well, for that, you'd want to use df7.drop, so the drop method. Note that this is also not an in-place operation, so your df7 data frame will not be updated with the deleted column. And yeah, let me delete the city column. You'd pass city for the column name, and then 1. And so the one argument means that you're about to delete columns. That's how you tell pandas or Python what you're about to delete. When you delete rows, you want to pass 0 there. So, and yeah, here, this is the on-the-fly data frame without the city column there. So again, df7 with city and drop. Let me drop 332 Hill st 0, and yeah, Hill Street is not there. And of course, if you want to update your data frame with the changes, you do that, and then when you print out your df7 data frame, the Hill Street is not there. And yeah, if you want to drop columns or rows based on indexing, you do a trick like df7 and then point to index, and then what do you want? Well, 0 to 3 maybe. So you're deleting rows, execute that, and you get the 3 rows only. Similarly with columns, and 1 in here. So you get ID, name, and state, the first 3 columns. So if that confused you, df7.index, what that gives you is a series with the names, so with the labels of your index column. So all this. And similarly, columns gives you the names of your columns. So that's how you access the header of your data frame and the index column. And yeah, that was about deleting columns and rows from the data frame. If you have questions, just feel free to ask them, and I'll talk to you in the next lecture. Good, we're continuing our series of lectures about manipulating pandas data frames. So you learn how to drop a row or a column out of a data frame in the previous lecture. Now let's see how we can add a column or a row to a data frame. So we have df7 here with address as index column and this series of column labels. Now, just to clarify something, I know this is difficult to wrap up your mind how you'll be using these operations in real life. So I just want you to know the syntax of doing these operations. And throughout the course, you'll learn how to actually put this into work with real life examples. So don't worry about that. And yeah, let's add a column there. To do that, you'd want to say df and in square brackets, you pass the name of the new column. Let's say continent. That would be equal to, now you would have to pass a list of values that you want to populate that column with. Let's say North America. Now if you execute that, you'll get an error. Name df is not defined. Actually, I didn't mean this error. This was another thing. You'll get this error. So it says that the length of values does not match the length of index. So the length of index is, length of index is df7.index. The length of your index is 5, but you're trying to pass their list with a length of 1. So you've got only 1 element there. So the solution here is to pass a list with the exact number of items that you have in your table, in your data frame. So we have 5 rows there, 5. And yeah, you could add 4 more items here, North America, etc. Or you can do some fancy things in there. So you could say df7 shape, then 0 times that. Execute. Df7, print that out. And yeah, we have a new column. So if you're confused with this shape, 0 times North America, what I did is, df7.shape, what you get is 5, 7, which means you have 5 rows and 7 columns. Now what I want to get is the first item of that tuple, so I get 5 by doing shape 0. With this I always make sure that I'm getting the number of the rows that my data frame has. And then when you multiply 5 by a list with 1 element, you get a list with 5 elements. America. That's the idea. Delete that. And note that this is actually an in-place operation. So that will update your data frame. And now that was about adding a new column, and how about modifying a new column? So modifying the continent column. That could be something like country, and you can also add some strings in there. Let's say plus a comma, plus maybe another string, North America. Execute that, print out the data frame, and yeah, see what we got. So what we did here is we updated the continent column by referring to an existing column, which was country, and then for each value of the country column, we concatenated the comma string, which you can see in here just after USA, And we also added another string, so North America. And this could also be another column if you liked. So if you passed here, let's say employees, you'd get 8 instead of the first North America, and then 15 and so on. So that's how you update a column. Now, how about adding a new row? Well, this can be a bit tricky, but still understandable. What you could do here, because there's no easy method to pass a row to a data frame, what you could do is you could say df7t, so I'm creating a new variable, that would be equal to df7.t. So t actually is a method that what it does, it transposes your data frame. And with transposition, I mean, you know, df7, if you check your new data frame, what you get is this. So your rows have become columns, and your columns have become rows. So spend a few seconds looking at this. Yeah. And what we can do now is, we can use the same syntax, df7t, and then add a new column in there. So for the name of the column, you'll have to pass an address. Well, let's say my address. That would be equal again to a list. And you want the list to reflect this order. So city first, let's say my city, country, my country, and 10 for employees, and 7 for ID, my shop for the shop name, my state, and my continent. Execute that, and df7t, if you look at this now, you'll see that you get a new column in your data frame. And now what you do so to complete the trick is, let me say df7 equals to df7 underscore t dot t. So df7 now will have the new row added at the end. So let me wrap this up. Again, what I did is I transposed the original data frame, df7, and then I added a column there. And now if I transpose the data frame back again to its original position, this column that I added will be converted to a row. And that does the trick. And similarly, you can modify a row if you like. So in that case, you don't point to my address, but you'd point to an existing column with an existing address name. For instance, this one, if I pass it here, and execute that, and that, and you'll see that the values of this row with this address name have been updated now, as you can see in here. And that closes this lecture as well. And yeah, I'll see you later. And yeah, let's close this section on pandas by looking at a real-world example. And in this example, what we're going to do is we're going to grab the address of each of these rows that we have in the data frame. We're going to convert it to a latitude and longitude coordinates. So geographic coordinates in other words. Now, addresses, they define a unique point on the Earth. So if you pass this address to some service, let's say you throw it on Google Maps, and Google Maps will point you, so it will generate a marker that will tell you where this point is located. Now, on the background, that marker actually has a pair of latitude and longitude coordinates. And every point on Earth has this pair of coordinates. And if you follow the section on building web maps with Volume in the course, then you know what these latitudes and longitudes, how they come in handy when you build applications such as web maps or other maps. Now, the process to convert from addresses to coordinates is called geocoding. And if you want to convert from latitude and longitude to addresses, that is called the reverse geocoding. In this lecture, we're gonna be looking at geocoding. So basically what we're gonna do is we'll add here a column to the data frame, actually two columns, one for latitude and one for longitude, for each of the rows. Now pandas cannot do that directly, so you need the help of another library that is called GeoPy. And you can install GeoPy with pip. So pip install and GeoPy. And just wait a while. Oh, great. And then, before going ahead and applying the geocoder to my data frame values, I'd like to actually convert a single address, an address string with geocoder. Something you should be aware of is that to use GeoPy, actually to use the geocoder, which is, if you say import GeoPy, and if you say GeoPy, like that, you'll see that you have a geocoder module among them, which is this one here, so geocoders actually. And for the geocoders to work, you need an internet connection, because what geocoders will do, it will get your address and then it will send that to an online service that has all these addresses in a database, and then for your address it will calculate the corresponding latitude and longitude values. So you need an internet connection. And yeah, what you normally do is, you want to import from geopy.geocoders import. Actually, there are a few geocoders there, but we will use Nominatim, which is a tool of OpenStreetMaps. And then what you do is, you create a Nominatim variable object. So you store that object in a variable, and that would be equal to the Nominatim class. So like that. And once you have that object, then you point to the geocode method of the Nominatim object, and you pass an address as a string in there. Let's say 3995 23rd, then maybe the city, and the zip code 94114. And if you execute that, you'll get a location data type there. So all this, and what that includes is, it includes the address that you pass there, so this one, and it has also added the United States of America, so the country in here, and you also get the latitude and longitude. And this one here, just ignore that, is just a response from the geocoder, so it doesn't mean much. Now sometimes though, it's rare, but sometimes you may get a non-object. So for instance, if you pass this address, which probably is not a real address, I'm not sure about that, I don't know, but if you say San Francisco, CA 94119, if you execute that, nothing will happen. And actually you can see that if you store this in a variable and then print n, this will say that it's a non-object, so it doesn't have anything inside. So yeah, be aware of these scenarios as well. And yeah, we had our working address, this one here. Let's store that in this variable. And once you have that, to extract the latitude and the longitude, you apply a latitude for the latitude value and a longitude for longitude, and that should do it, because n, type n is a special object, it's called a location object of GeoPy, so you need to apply those methods. And yeah, that's how you convert an address string to a location, or to latitude and longitude values. But how about converting an entire column of a data frame into latitude and longitude? So we've got this data frame, df equals to pandas.read CSV. So super.csv, and this should be an underscore, and let me import pandas first and print out the data frame. So this is our new data frame. Actually, this is the old one that we've been using. We have 6 addresses there, 6 rows with an address, a city and state and country. Now the geocode method, more or less, it accepts this kind of format. So it expects from you the road name in here, and then the city, and the zip code in here, and the country. So what we can do is we need to construct such a column in our data frame first. And yeah, you can either create a new column or you can edit an existing one. So let's say I'll edit the address, the existing address column. So that would be equal to df address, so this value in here, plus, well, I'll need a comma in there. So a comma and maybe a space, and plus df city, so a comma between address and city, and then another comma, and then plus df state again, and yeah, yet another comma, like that, plus again df, and lastly country. That should do it, df. And yeah, we've got a complete address column in there. Great. And now we need to send this string to the geocode method. And we need to do it for all the rows. You're probably thinking of iterating, but with pandas, actually, you don't need to iterate. I mean, pandas is designed in a way that it allows you, it has some methods that allows you to apply a method or a function to all the rows of the data frame without having to write a for loop. And to do that, you need to create a new column. Let's call it coordinates, where you store the string. This string in here. So this actually it's not a string, it's a location object, but you can store it in your data frame. So we need to store locations for each of the rows, and the way you do that is you point to the column that you want to pass to your geocoder, and then you use a pandas method called apply. So what method do you want to apply to the values of the address column? Well, that would be n. So n is a nominatum object that we have here. Oh, sorry, it's nom. Sorry. So that would be nom.geocode. And so the same as this one. So nom.geocode. But in this case, you don't pass brackets there, because the apply method will do it for you. So just like that, and then you print out the data frame in there and see what you get. I got a service timed out. The geocoder is not working properly. Maybe I have a problem with my internet connection. So if you get this long error, that is not your fault. It's a problem with the geocoder with GeoPy. I'll try that again. And yeah, this time it worked. It was able to fetch the location objects in here. I mean, you cannot see the latitude and longitude because it's a long string. But if you do it like that, coordinates, you get the series for coordinates. And yeah, that is not showing it either. But you can do it like, df coordinates, and then you access the first item only, like that, and then you get the entire text for the location. If you want the latitude, you get latitude only. And that brings us to the point that you may want now to add another 2 columns in your data frame where you fetch the latitude and the longitude values. So our data frame is this one at the moment. And what you could do is, you could create a latitude column in there. That would be equal to df coordinates apply. You cannot apply latitude directly in there because you'll get this kind of error that says series has no attribute latitude. So you're applying a latitude method to a series, but a series doesn't recognize that. What series recognizes is the apply method. So there you can write your other methods. Now latitude will point to the values of this coordinates column, and in such scenario you use a lambda function, so which is an inline method to build the function. So you'd say lambda x is a temporary variable there, you say x latitude, and yeah, let's keep it like that for now. Df there, and let's see what we got. Well, it says that a non-type object has no attribute latitude. So this can be quite tricky if you're not experienced with geocoding. Yeah, the reason we get this is that we have a non-row value in there among our rows, and the non-row, which is not a location data type, does not have a latitude method. Because what we did here is we're storing all these values, so it's like a loop. We are storing all these values in the temporary x variable, and then for each of these value we apply the latitude. So what Python will do is it will go through the first row and it will apply the latitude methods to the first row, and it will store it in the latitude column. And then it goes to the second value, but in this value latitude is not existing for none, so you get an error. To do that, you could apply a conditional, an inline if conditional. You say if x is not none, else none. Yeah, I know it's a bit confusing, but what we did is, apply latitude if x is not none. So it will apply this method for those rows, for those values. Otherwise, it will store none in the current cell of the latitude column. So I hope that is clear. I'll execute here. And yeah, we got the latitude column in there. Great. And we can do the same for a longitude. Longitudes. And here as well. Yeah, that was quick. And yeah, that's it. You have a latitude and longitude column in your data frame. So please have a second look at what I wrote in here. And if there is something that doesn't make sense, just drop a question and I'll be happy to answer you. So yeah, we have quite a lot of flexibility working with data frames. I hope you enjoy this, and I'll talk to you in the next lectures. See you. Consider this grayscale image. Now this image is made of pixels. This particular one has 3 by 5, so it has 15 pixels. So it's quite a small image. Now each pixel has a value, and that's what defines the intensity of the gray color for each pixel. So in reality these are numbers, but our computer display shows them in a color format, which is easy readable by us humans. Where I'm trying to get is that programs use numbers to store images. Then the computer display, or so the screen, converts these numbers to colors. Python can also do image processing, just like Photoshop does. Probably it cannot do all the cool stuff that you can do with Photoshop, but you can make use of Python to automate things. For instance, we'll be using the image processing capabilities of Python to detect faces from photos, from images, and also detect moving objects in videos as well. So videos are made of images, so it's the same thing basically. And Python stores and reads images using arrays of numbers. For instance, this image could be represented as, you know, a list of 3 other lists. So 3 lists because we have 3 rows there with pixels, and then in each of the lists you'd have like 5 numbers, and so on and so on, and the 5th, and the same for the other 2 lists. We've got 5 numbers because we have 5 columns, so 5 pixels for each row, and that's an image for Python. And here is where NumPy comes in handy. So while you can represent images with lists as we did here, this is not very efficient because for big images, lists occupy lots of memory and therefore they slow down operations on them. So this is solved by NumPy, which is a library, a Python library that provides a multi-dimensional array object. So let me go ahead and create this array object. First of all, what you need to do is you need to import NumPy, and if you have installed pandas, NumPy should have been installed with pandas because pandas is based on NumPy. If you haven't installed NumPy just yet, just go ahead and pip install NumPy. And if for some reason you have some problems on Windows, then just go ahead, as I've showed you, and find the precompiled Python libraries. Go to this side and then search for NumPy. And then figure out if you're on a 3.5 version of Python, then just get that version. And then you point to this file with pip install and the name of the file. Great. Now I have NumPy installed, so I'll create this multi-dimensional object and store it in the n variable. That would be numpy.arange, and let's say 27. Execute that and print out n. So this is a NumPy array. That's how it is called. This particular one is not exactly a multi-dimensional array because it only has 1 dimension. So it's like a plain list, a Python list, but still it's not exactly a list type. Sorry. So it's a NumPy n-dimensional array. It can have 1 dimensional, 2 or 3. So we have 1, 2, 3, and I'll show all these scenarios. So that was the 1-dimensional array, and if you want to print it in a nice form, and that would be the array. Now, I'm just creating a NumPy array using numbers on the fly here, but normally you'd have to create arrays from images, and we'll do that in just a bit. So for now, let's create some arrays manually. Now, let's see what 2-dimensional array is. Shape 3 by 9. So we already have this 1-dimensional array, and we want to convert it to a 2-dimensional array. If you execute that, you get a 2-dimensional array. So that's a 2-dimensional array because it has 2 dimensions. So think of it as this image file. We have 2 dimensions, vertical and horizontal. Now, what's a 3-dimensional array? Even though 3-dimensional arrays are less frequently used, it's still good to know about them. And yeah, let me create a 3-dimensional array. I could say 3 by 3 by 3, because you know you have 27 elements, so 3 by 3 by 3 gives you 27. And yep, that's a 3-dimensional array. Think of that as a cube that has 3 dimensions, so 3 by 3 by 3. And practically you'll see that in just a bit in this lecture. Where do we deal with 3-dimensional array? So bear with me. And yeah, you're able to see the similarities between a NumPy array and a plain Python list of lists. So this here would be like a two-dimensional array, if you like to call it like that. Yet the structure in the low level is different between Python lists and NumPy arrays. And also NumPy arrays allow you to make some more efficient operations such as iteration between the array items and so on. And you can also create NumPy array out of Python lists. For instance, I'll get this list here and I'll create a new object and then point to NumPy. And to convert a list to a NumPy array, you'd want to use asArray method. And then between the brackets goes the object that you want to convert. And that's an array, which is almost exactly like this one in here. And if you print that, you wouldn't be able to see the difference. You know, they look exactly the same. But they are not, because this is a list and this is a NumPy array. Great, let's move on. So that's NumPy, and as I mentioned earlier, NumPy is a base library for other libraries such as Pandas and also OpenCV, which is an image processing library. So Pandas data frames are based on NumPy arrays, and OpenCV objects are based on NumPy arrays. So what Pandas does is it just adds some cool features in there, such as it gives capabilities for having table headers and indexes, which you can't have in NumPy, because NumPy is meant to be a more simple and in a more low level of storing objects and doing operations. And so NumPy is a requirement for many libraries. And yeah, let's stop this lecture in here, and in the next lecture we'll go straight ahead and create a NumPy array out of our image in here. So this image. Okay, see you there. And yeah, CV2 is installed. And now what I can do with CV2, among many other things, what I can do, the very first thing, is to load an image in Python using CV2 methods. So I'll be loading that image, which is a very small image, by the way. It only has 15 pixels. You know, a normal image that you use to take pictures or on your phone or whatever, it has like 1,000 by 1,000 pixels, which is 1 million pixels, more or less. But we should keep things simple so you understand what is going on. CV2, import that. And yeah, that was successful. And now I'll create a variable and call this IM for image and G for gray. You can call it whatever you want. And CV2, to read an image, to load it in Python, you want to use ImageRead method. And then you pass the name of your image. You can find this image in the resource section, so just go ahead and download it. And now this is here in the same directory with my Jupyter notebook, so I can go ahead and point to the name of the file, including the extension smallgray.png. And here the ImageRead method also expects one other argument from you, and that can be either 0 or 1. So 0 means you want to read the image in grayscale. And if you pass 1, you're reading the image in BGR, which means blue, green and red. And you'll understand what each of the versions mean. So let's do this one first. And yeah, I'll print that. And yeah, that was it. So what we got is a NumPy array. It's a two-dimensional array. So it has dimensions 3 by 5, which is the same as our image. 3 rows and 5 columns. Now the reason we pass 0 there, so we're reading that as a grayscale image, is because, you know, this PNG file, in reality it has 3 bands, or you can say 3 layers, and each layer has a certain amount of colors. So for the first layer has a certain amount of blue, and the second layer has a certain amount of green, and the last layer has a certain amount of red. So combining each pixel is a combination of the intensity of blue, green and red. I know in other programs they use RGB, in OpenCV uses BGR. Now practically this file here, this image practically is a grayscale image. However, each of these pixels has its own bands, so the combination of them always creates, in this case, these gray, white and black colors. But if we had a color image there, this would convert it to a grayscale, this function. So again, what we have here is, 187 is the value, the intensity for this first pixel. And then you have the other number, and for white, you see white here, we have 3 white pixels. And those are 255, all of them. And yeah, colors range from 0 would be black, pitch black, and 255 for white. And everything between them is in the grayscale. So now if I change this to 1, I'll get a 3-dimensional array, where this represents the blue layer, the green, and the red. Or you can even print that out. Be careful though that this is a bit transposed, so the matrices are 3 columns in here and the rows are vertical. And basically what this says is this pixel has these corresponding values. So it has an intensity of 187 for blue, 198 for green, and 209 for red. And yeah, that's how you create NumPy arrays out of images. But how about the other way around, so creating images out of an NumPy array? Well, to do that, you'd use CV2 again, CV2, and then you'd point to the imWrite method, so imagewrite, and then you want to pass a name for your image, let's say new small gray.png, and then of course you need to pass your NumPy array. So let's pass image gray. Execute that, you get true, which means that your file should have been created now. Yeah, new small gray, and yeah, that's the file. And I hope that strengthened your knowledge about NumPy. Now we'll go ahead and do some more things here. Specifically in the next lecture we'll learn how to do indexing and slicing and iterating of NumPy arrays. So basically you'll learn how to access these values. See you there in the next lecture. Alright, you know how to slice lists. So 0 to 1 will give you the first item of the list, and 0 to 2 the first and the second item of the list, and so on. With NumPy arrays, you do basically the same thing, except with NumPy arrays sometimes you have 2 or more dimensionals, or 3. So let me go ahead and I'll start with a 2-dimensional array. So I'll get that from this variable. So this is the NumPy array that we'll be working with. And yeah, if you want to extract this number here, this here, this one, and this, so these 4 numbers, well, you'd first need to set the index of the rows that you want to slice. So that would be 0 to 2, which gives you the first 2 rows. Actually, we can try that, and you'll see that you get the first 2 rows. Now if you want only this portion here, so these 2 numbers and these 2, you'd want to pass a comma there, and then the index for the columns, which would be, 0 here, 1, so 2, 3, and yeah, 2 to 4 maybe, yeah, that should do it, and that's it. And that means you have this indexing system, so it starts from 0 for rows, and then the second row is 1 and 2 and so on. For columns, the same thing, 0, 1, 2, 3 and 4. And actually, if you like, you can see the shape of your NumPy array. So it's 3 by 5, which means 0 to 2 and 0 to 4. Great. And of course, you can use the convention of list indexing, so you can pass 0 and everything after that, or just like that. So you get all the rows and only columns from 2 to 3. Similarly, you can get only one value if you like. Not particularly this one, because 3 is out of the bounds for axis 0. So axis 0 is a horizontal axis, which says that there is no row with index 3. So we set it's 0, 1, 2. So let's pass 2 there. And you get 182, which is the very last item of the NumPy array. And yeah, that's about indexing. How about iterating through a NumPy array? Well, there are two ways to do that. The first way is to say, let's say for I in your NumPy array, print I. What that will do is it will print out the rows of your NumPy arrays. So what this I accesses in your NumPy array is the rows. So in each iteration, it gets the first row and it prints it out in the first iteration, then the second one, and then the third one. And if you want to iterate through columns, you'd want to access the transposed version of your NumPy array. And that's how you do it. And lastly, if you want to iterate value by value, you'd say for I in image and dot flat print I. So this property, what it does is it allows you to access values of your NumPy array one by one. And that's about indexing, slicing, and iterating. I'll see you in the next lecture. Alright, now that you know how to do slicing and iterating through NumPy arrays, let's do some more specific operations. That would be stocking NumPy arrays, so concatenating NumPy arrays to each other, and also splitting a NumPy array to smaller arrays. Yeah, I have this NumPy array still here, so let's start with stocking two NumPy arrays. To do that, you may want to create a new variable where you'll save your big array, and that would be equal to NumPy and the method to stock two NumPy arrays. Actually, there are two methods. One is horizontal stack, so hstack. That expects from you to pass two or more NumPy arrays that you want to stack horizontally. So let me pass OMG and then the same array. It's not a problem. If you had two different arrays, you could do that, but I'm just passing the same array there. Now, if you execute this, you'll get an error, and I want you to see this error so that you understand it. So it says hstack takes one positional argument, but two were given, which means that hstack inside the brackets it gets only one argument, but we're passing two. So how do we go about concatenating two NumPy arrays? We can't just pass one NumPy array there. So the solution here is to have a tuple of NumPy arrays. Just like that. So a tuple inside the input of the hstack method. You execute that. And here is a stacked array. Yeah, so this is the first array and then the next array, which in this case happens to be the same one, but if you want you can add more. And you get a longer array, which is not very good looking like that, so you can print that out. And yeah, now you see the difference. So the first array, the second, and the third one. And if you want to stack vertically, you'd want to do V there. And yeah, as you expected, this will concatenate the arrays in the vertical position, in the vertical axis. Be aware that if you try to concatenate arrays that have different dimensions, you'll get an error. So IMC has 3 dimensions, if you can remember that from up here. Now you'll learn how to concatenate and how about splitting an array into smaller arrays. Well, to do that, you could create a variable and then numpy dot horizontal split for splitting horizontally, and then this expects a numpy array and how many arrays you want to produce out of that. So horizontally, let's say 3. And yeah, this says array split does not result in an equal division. The reason to that is, this array has 1, 2, 3, 4, 5 columns. So you're trying to divide 5 by 3, and NumPy cannot decide how to do that. So should it give to you a NumPy array with these 2 columns first, and then another NumPy array with 2 columns, and then a last NumPy array with 1 column? So NumPy cannot do that. Yeah, what you should do is maybe 5 there and LST. And that should give you 5 different NumPy arrays, which in this case happens to be, 1 array for each column. And you can do vertical splitting. This time we can try 3 because we have 9 rows there. And yeah, we get 3 small arrays. Note that this LST, so the split, what it produces is a Python list of NumPy arrays. So it's a plain Python list. And out of that you can access each of the NumPy arrays if you like. You know that. So it outputs the first array. And yeah, that's about concatenating and splitting NumPy arrays. Hope I gave you a good overview of NumPy. I tried to do some practical examples like opening images, but this is still yet in the theoretical part, so NumPy is quite theoretical, and you only understand it when you get to use like this real-world examples like working with pandas as we did previously in the course, and also working with images. So we're going to do some hardcore image processing in the next lectures, in the next section. And you'll see how NumPy comes in handy in there. And yeah, I hope you enjoyed this, and I'll see you later. Hey, hi again, and welcome to this new section of the course. And in this section, you're going to build the second application of the course. And specifically, what you're going to build with Python is this web map that you see here. So a web map is a map that is displayed through a browser and can be visited through the web. So, this map was built with Python and Folium. Folium is a Python library, and the map has 3 layers. It has a base map layer, the one that you see here, with its names on the back, and it has a polygon layer, which represents the population of the countries, and also we have this point layer here with these dots, and you can turn on and off these layers. You also have these pop-up windows. So this is what you're going to build, and yeah, let's go ahead and do this. See you in the next lecture. Hi again, I hope you followed the previous video where I presented to you the map that you're going to build in this section. So that was a web map, and as you may realize, to build that web map, the default Python installation is not enough, because logically, Python cannot have every possible functionality by default, because if it had all the functionalities, then Python would become very heavy. Therefore, it's a smart choice to have external libraries that you may choose to install or not. And this is the case of web mapping. So to build the web map that I showed you in the previous lecture, you need a library, a third-party library, which is called Folium. So as you may realize, you need to install that library. Now, just a note, I had some previous videos about this section, some old videos, but I had to change them, so I'm recording new videos now. This is a new video, updated video. and all the next videos of this section, because Folium had made some changes in the code compared to the previous versions, and therefore I had to remake the videos. Now, this time I'm using a Mac computer, but that will not make any difference. So if you're on a Windows, Linux or Mac, everything will work exactly the same. The only difference is the way you open Atom, of course. So on Windows, please create an empty folder where you'll be keeping the files for this project. So my folder here on Mac is mapping, and on Windows you can hold the Shift and right click, and then go to Open Atom here to open Atom in this folder. On a Mac, you can press Command space Atom. And then go to View, Developer, open in Dev mode, and then locate the folder and click Open. And yeah, that's it. I'm going to close all this. Let me open the terminal, and now go ahead and install Folium. To do that, you need to type pip install Folium. Normally you'd have to do this on Windows. On Mac, if you have 2 installations of Python, you may need to do pip3. So that will explicitly say to install Folium for Python 3. So Folium was installed successfully. If you have a message saying that Jinja 2 is required for this package, then just go ahead and do pip3 install Jinja 2. However, I expect that Folium will install Jinja 2 by default, as it did for me, so it should be good to go. Once you've done that, I'm going to open Python, actually Python 3. On a Mac, you need to specify Python 3 explicitly. And what I'm going to do now is I'm going to create a basic web map. And I'm going to use a Python interactive shell for that, so that I show you things around. So try to import Folium. If you get no errors, that means Folium has been installed successfully. Now, how does Folium work? Well, everything spins around a so-called map object. So the very first thing you need to do once you import Folium is you need to create a map object. So I'm using a variable to store that map object, and then equal to Folium.map. So this is the class that creates this object. If you want, you can actually check dir Folium to get a list of available objects that you can use on Folium. So here is map. Ignore the others for now, we'll go through them later. You can also ask for help now, Folium.map, to see what you can pass to this map object. Create a map with Folium and leaflet.js. So what Folium does is it actually produces, you use Python, so you write Python code, and that Python code will convert automatically to JavaScript and HTML code and CSS code. Because you need JavaScript, CSS, and HTML to create web maps. You cannot do that with Python code directly. So the browser reads HTML, CSS, and JavaScript and renders the code of these 3 programming languages to elements, so like text and lines and points and pictures. So that's what Folium does. And that's a wonderful thing that you can do that with Python, through Python. Anyway, you can look here, down here in parameters. You can pass a location parameter in here. And you can specify the width. Anyway, if you don't specify the width, a default width of 100% of the browser area will be used. So you don't have to pass width and height as well. And then you have tiles. Default is OpenStreetMap tiles. So tiles is the background of the map. You're going to see that in a minute. You have other parameters as well, which you can look by yourself, I believe. Okay, I pressed Q to exit the help, and let's go ahead and create the map object finally. Volume.map. So location, you need to pass a location parameter there so that the map knows where to open. So it may open, let's say, near Alaska or near Greenland or South Africa. We're talking about the initial view, but then you can zoom in and out. So let me pass a random location. Locations, by the way, are given through coordinates, and by default you need to pass geographic coordinates, which is latitude and longitude. So latitude ranges from -90 to 0 to 90. So let me pass 80 there. By the way, this goes inside the list actually. So 80, a comma, and then the longitude. The longitude ranges from 0 to -180 and 0 to 180. Let me pass -100 and close a bracket. So you pass a list of coordinates to location, and actually that's enough. You can have a map object with that. Execute, you don't get an error. That means everything is working fine. So now you have a map object, but that's just an object inside Python. You haven't translated that object into HTML and CSS and JavaScript code just yet. So what you need to do next is point to that map object and then use the save method and then pass a name for the map file that will be created. And of course the maps will be created in HTML format. So HTML is what contains all these elements that render on the browser, so text and visuals and so on. Close the bracket, execute, and as you see, a file was added in here, map1.html. But let me go to the folder, double click that, and that will open in your default browser. So this is just a random location. I don't know what it is. Magan Island. Oh, that seems to be in Canada, very north of Canada. Yeah, this is it. This is the web map. If you zoom in, you'll see more details on the map, like that. So the more you zoom in, the more elements you see. Yeah, that's what I wanted to show you. And if you want another location, you'd want to change the coordinates in here in location. But if you don't know what coordinates your favorite place has, then there may be different ways to discover that. But a quick way is to go to maps.google.com. Let's say you want to know the. Let me zoom in here. You want to center the map around this location. So right click there and go to what's here, copy these coordinates, copy those coordinates, or if you cannot copy them, just remember them. So 38.58 approximately, and minus 99 times 09. Okay, then you need to save the map again, map1.html, and that will override the previous map. So go here, reload, and you see now we have a different center of the map. And of course you can also play around with the zoom, so you can add a zoom parameter in here. This is called the zoom start. Let's put it at 6. Don't forget to close the brackets in here. Okay, execute. Upper arrow key to call a previously executed statement, like map save. Well, you can also choose to go to the browser and reload with Control R or Command R, and that will show you the new map with another zoom factor. And yeah, that's about it. Try to play around with this a little bit, and in the next lecture I'll show you how to add points to this map. I'll see you there. Hi again, and welcome to this new lecture. In this lecture you're going to learn how to add points to the map that we built previously, which is this one here. So all we have here is a base map, so the background map, which is a layer. Actually, it's a layer coming from OpenStreetMap service. So OpenStreetMaps, they give you a layer. Actually, Volume will serve you this layer on the background through JavaScript. But you can also add other layers as well, other base layers, and also points, which you can add on top of the base layer. So let me go back to the code. This is what we wrote in the previous lecture. Actually, we wrote it in here, in the interactive shell, but I just copied and pasted this in a file so that we have it and that we can add more code now on top of this. So again, as I told you, you can do help volume.map, and you see you can add other things in here, such as, here you have parameters, so you can add tiles. The default is OpenStreetMaps, but if you specify another tile such as map box bright, and that has to be in quotes, as you can see in here in the tiles parameter, this expects a string object. Location, for instance, it expects a tuple or a list, and that's what we passed. We passed a list of coordinates. The width would be an integer, the height, and so on. You have other options as well, which you can try by yourself. I just want to try this one for now. Let me open a new Python shell, Python 3 map 1. Make sure you have saved your script. Execute. Then you can go back to the folder and open map. Let me go to Firefox, Control R or Command R to reload, and you'll see that the background has changed, so we have a new base map now. Okay, let's go back to the script now, and what I'm going to do is I'm going to add some point markers on top of the base map. And so how do you do that? Well, if you do dir volume, here you can see that you have some objects, and the one we want is a marker or a circle marker. So I'll try them both, but I want to explain you the logic of how you add objects to the map object. So we import volume, we create a map object, and then between the map object and the save method of the map object, you can add elements, so objects, to that map. And what I want to add in this case is a marker. So I can do map dot add child. So we use the add child method to add children. So these objects that I'm talking about are referred to as children when you add them to the map. So map add child, and then you want to point to the volume dot marker. Now this marker method, this expects some arguments itself. You can do help volume dot marker. So create a simple stock leaflet marker on the map. Leaflet is a JavaScript library that helps you to visualize this. That is the engine that creates those maps on the browser. So Python creates a JavaScript code using the leaflet library. And so markers allow you to add pop-ups. So when you click a marker on the map, it allows you to show information. And so parameters, you need to pass a location parameter to the marker in order to visualize it. So location equals to, so it's a tuple list, let's say 38.2 and minus 99.1, and you can also pass, so after the list, a pop-up parameter, which could be like, hi, I'm a marker. And you also need to pass the icon parameter, which actually is another object, and that comes from volume.icon, which expects from you to pass a color there, like let's say green. And yeah, basically that's it. Make sure your brackets are correct. So have 3 brackets here, 3 closing brackets, and 1 and 2 and 3 opening round brackets. Okay. Save the script. Go to the other terminal and execute. Go to Firefox, reload. And here is the marker. If I click, I get the pop-up message in a nice window here. So that's how you add markers to your map. However, I would suggest you follow a slight different approach to add children to your map. What I would suggest is to actually create a feature group, volume.feature group, and you can give it a name like my map. And then what happens is that in this feature group, so the marker is a feature, and with feature groups you can add multiple features to the feature group. So you can add a marker, you can add like polygons, etc. And so instead of saying map, you do the feature group object. So this variable that I created in here, I'm passing it here, and then after that you do map.addChild, and you pass the feature group in there. So this is more. So this is done to keep your code more organized, and it also helps you later when you want to add a control layer control feature in your map to allow you to switch the layers on and off. So we'll look at this later. Save this script and let me try it. Reload the page. And so we don't have any change. Things will work the same, which means feature group is working fine. But as I said, it's good to keep the code organized, and it also helps you later when you add a layer control feature. That's what I wanted to teach you for now, and I'll talk to you later. Great, we were able to build this map in the previous lecture. So we have a base map and we have a marker feature here. And this is our code. Now in this lecture I'll show you how to add multiple markers to your map. And the way to do that is to, one of the ways to do that is to write this expression multiple times. So like that, and of course you need to change the locations of those markers. Save the script and execute, reload, and so you have multiple markers. So as you realize, it's not possible to add multiple markers with one single method. So with one single marker method, you need to apply the method multiple times. However, this is not very smart to do. And that's the beauty of programming. You can use a for loop to actually add multiple markers to the map. So we're talking about the Python for loop, which is one of the fundamental features of Python. So the for loop has nothing to do with volume. Let's say for coordinates in, of course you need some sort of input with the coordinates. I don't know, let's say like that. Let's say a list of lists. So we have these two coordinates. Let me copy this, put it there, and another time, and let me change them to 9 and 7. And then you need to indent this with 4 white spaces. I'll explain this in just a bit. And then in location, you need to pass coordinates. Before explaining the code to you, let me try this out. Execute. Go to reload. And yeah, we still have the markers there. Of course, the location changed from the previous one because I changed the coordinates in here. So how is this working? Well, I'm iterating with a for loop through this list of lists. So the items of this lists, of this main list, are 2 other lists. So the items can be anything. In this case, there are 2 lists. So what happens is that the coordinates variable, in the first iteration, it will get this first item of the list, and it will put that small list, so 32.2 minus 99.1, it will put that list in here. So basically this will be put in here, more or less. That's the idea. And then in the next iteration, coordinates will fetch this other list and it will put it in here again. And so the marker method will be executed 2 times. And so in the first time it will generate a marker with this coordinates, and then in the second iteration it will generate a marker with these coordinates. And that's it. However, we have a small issue here, and the issue is that, in reality, you cannot just type the coordinates in a Python list. Let's say you have 1,000 coordinates that you need to map into a map, and you cannot and it's hard to type them in here or even paste them, copy and paste them from a document in here. So the solution to that is that your coordinates normally in real life, they will come as maybe a text file, like a comma separated text file, CSV, Excel files, etc. You want to load that file into Python, and then you want to add the values of that file into the marker method. And you can do that using a for loop. And how you do that exactly? Well, I'll explain that in the next lecture. Well, I'll give you a comma separated file with lots of coordinates, and we're going to use that in this script. So I'll talk to you later. Hello, in the previous lecture you were able to build this map with multiple markers. This map happens to have only 2 markers, but you get the idea. And the script was this one here, so you can add as many coordinate pairs as you want in here. But in this lecture I want to show you how to add pairs of coordinates out of a text file, which is this one here, volcanoes.txt. If you like, you can just rename the name of this from volcanoes.txt to volcanoes.csv, and then you can open it in a program such as Excel. If you like, you can show it on a plain text file as I'm doing in here. Python can read both CSV and text files. So what we have here are some data about volcanoes. Basically we have the number of the volcano, which is some sort of ID, so volcano 020. We have yet another number then, and as you see, every column, so we have columns in this data file, and every column is separated by a comma. This is the name of the first column, which the first value of this first column is this one here. Then A is the name of the second column. The first value of the second column is this one here. Then the second value of the second column is this, and so on. And then we have the name column, the name of the volcano in here. The name is here, Baker, and then the comma starts here, which means that location is this one here, US Washington. Then we have the status historical for the first volcano. And then we have the elevation, which is this one in here. I'm not sure whether these are in feet or meters, but you can find that out. If you're curious, you can do a research for this particular volcano and compare the elevation. Anyway, then we have the type of the volcano. You have the time frame, which is D3. I'm not sure what this means. D4. And so then lastly, this is where we're interested about. We have the lat and lon columns. So this is lat, which means latitude, and this is longitude of the volcano. So you need these two numeric values in order to map the features, so the volcanoes, into a map, in this case into a volume map. So this has around 63, actually 62, 63 including the header of the data. And so how do we load this file into Python? Well, to load that file into Python, let me clear the terminal. And you'd first need to install a very useful library called pandas. We're going to use this library later on, so I'm not going to explain pandas in detail for now, because we were just using one or two of its functions, which I'll explain in this lecture. So go ahead and install pandas if you don't have pandas. Pip install pandas or pip3 install pandas, depending on how you have configured Python. And then you can go ahead and open a Python session. Import pandas. And the way to load a file with pandas is by pointing to pandas.read CSV volcanoes.txt. Make sure that your Python session has been opened in the directory where your volcanoes.txt file is. So for instance, my session is inside mapping folder, which is this one here, so I can just pass the file name. Otherwise, you may have to pass the absolute path of the file, which starts from like C// and so on, depending on what operating system you are in. And execute that and call data, and you get the data printed out. Just like that. And so pandas is able, actually the read CSV method is able to distinguish between these commas, where the commas are, and so it creates a well-structured data format with columns. So if you go down here, so you have some columns here, column, and then up to the end. And then you have other columns because Python cannot print out. Actually, the terminal doesn't allow you to have all the columns in one inside with this area here, because it would be too much. Anyway, you have status, elevation, type, time frame, lat, and lon. So that's about the data. Now you need to figure out a way to iterate through that data frame. So this is called a data frame. So the data object is called a data frame. You can check its type actually. Pandas core frame data frame. So what I'm thinking of is to actually create two lists out of these data frame columns. So to put the latitude column in a Python list and the longitude column in another Python list. And so that we have a native Python object, which is a list, and then we can iterate through that list using the for loop. So let me try to do that. Import pandas, and then create the data frame object. So loading the data, read CSV volcanoes.txt, and yeah, that's it. So how do we convert a data frame column into a list? Well, the way to do that is by just doing, let's say L or lat equals to data, and then the name of the column, which is lat. So you can get a list of columns, by the way, by doing data.columns. Here you see you have a lat and a long column. Then you do lat equals to list data long in square brackets, close it. And so what you did here is data with the long attribute there will return a series object, but that series object we are converting it into a native list. So that will be a Python list. This will also show up as a similar object. So this is a series object, and this is a list, but I prefer to work on a list because working on lists is faster than working on data frame series. So the idea is to have two lists here. That equals to list data long. Copy that, paste it here, and the same thing goes for longitude. So long, lat, and long lists. So now we need to be careful here on how we iterate through these two lists, because you know what we have is we have two lists, and each of them has 62 items. You can check that using len here, down here, lat. So it has 62 items, and the same goes for the longitude list. That means that the first item of the latitude list corresponds to the second item of the latitude list. Of the longitude list. So the first two items make up the first location of the first marker. That means that in the first iteration we need to extract both locations. So actually this sort of structure won't be appropriate anymore. What you need to do is you need to go through, let's say, lat and long variables. When you iterate through two lists at the same time, you need to use the zip function, and then it goes lat and long. So basically what this function does is like this. Let's say for I, j in zip, let's say the first list is 1, 2, 3, and the second is 4, 5, 6. Print I and j. So this is what happens. This loop will go through these two lists at the same time. So what happens is that I will go through the first item of the first list, while j will go through the first item of the second list. And so in the first iteration, 1 and 4 are extracted. So 1 here and 4 here. And you can do such an extraction by using the zip function. Otherwise, you won't be able to do that if you don't use the zip function. So zip sort of distributes the items one by one. And so the same goes here. LT will get the first item of this list. L1 will get the first item of this list. And then here, what you need to do is you need to construct a list with LT and LN. Yeah, that's it. Save the script, go to the terminal to execute. It's not here, the terminal. I'll just exit that. Python 3 map1.py, execute. No errors. Go to Firefox and reload. And I've got no markers for some reason, but I didn't get an error. So this is one of those scenarios where you don't get an error in the terminal. So in that case, you need to double check your code carefully. So data pandas3 CSV lat list data long. Here's the error. So what's happening is that I'm assigning the wrong column to the latitude list. So let me change the order and try again. So don't get intimidated by errors. Errors happen all the time. You just need to be cold-blooded and read the errors if you get any error here, and also look at the code carefully. And let me reload. I've got some markers now. So these are the locations of the volcanoes in US actually, United States. Okay. They also have this pop-up, which is working well, but I assume you don't like it very much because it's not showing any information. So what we need to do here is to actually make this pop-up dynamic so that it shows some actual information. And I'll show you how to create dynamic pop-ups in the next video. Talk to you there. Hi again, in this video I'm going to show you how to add the elevation values, so these ones in here, to the pop-up window. Currently our script simply prints out this string in the pop-up window, so we're going to change that, and the way you do that is by first loading the elevation data into a Python list. And then in the loop here, you want to say, let's say L in zplat_lon elev, like that. And here in the pop-up argument, you pass the L attribute. So again, we create a list which is named elev, so variable elev. That will be a list of all the elevations, and then we iterate through these three lists. So LT will get the first item of lat, LN will get the first item of lon, L will get the first item of LF, and those items will be distributed in this function in here. So LT in here, LN in here, and L in here, EL in here. Now I want to save this and execute, but I expect to get an error, and I want you to see the error so that you get familiar with handling errors as well. So the error is happening on line 14 in this file map1.py, which is our file. Line 14 is here, so this is the line, and then we have add child pop-up. So it seems this error has to do with the pop-up object. I would say this is not a very good error message actually. It's hard to read this error and to troubleshoot it. So not very good information given by volume here, but anyway, we have some clues. So pop-up, and this says name child get name attribute error numpy.float 64 object has no attribute get name. So it seems that Volume is trying to apply this getName method, which is a method inside the Volume code base, and it's trying to apply it to a number. So I think that this L here is actually a number, and I can check that by saying print type L, save, execute the script. And yeah, here is the type. So this is a numpy float 64. So basically it's a float type It's actually a special float of the NumPy library, but anyway, you can call it a float. So it's a number, it's not a string. But if you look at help volume dot marker, you'll see that the pop-up parameter expects a string from you as input, but instead you're passing a float number. So you don't want to do that. What you want to do is simply convert that float number to a string. Save the script, go to the terminal, execute again, go to Firefox, reload, and you get the elevation displayed correctly. Yeah, that's about it. You can also you may also want to stylize what you're displaying, so to add more information there, such as plus space meters. So I'm adding the M string to every pop-up window information for all the elevation numbers. So we're talking about 2447.0 meters. That's the elevation of the volcano. Yeah, that's the idea. I hope this was clear, and I'll talk to you later. Hey, hi again, and welcome to this new lecture. What we have so far is this map with these 62 markers, each of them representing a volcano location in the United States. However, this map is not very smart, so to say. The only information that this map conveys is the locations of the volcanoes. And you also have a base map. There's also a good aspect of this map because you can extract information like that if you click the icons. However, you may want to transform this map to actually show an attribute instead of just volcano locations. The way to do that, there may be different ways, but that's up to your knowledge about cartography. But I could make the map show an attribute here. For example, I could change the colors of these markers to actually show the elevation range. Let's say we can categorize these markers into 3 colors. Let's say green, orange, and red. Green would be for elevations from 0 to 1000 meters, for example, or 2000 meters, and orange would be from 2000 to 3000 meters, and then red markers would represent volcanoes with an elevation of higher than 3000 meters. So how do we do that with volume? Let's get back to Atom. Here is our code, what we have so far. Currently, what we're passing to the icon argument is a color argument with a value of green. So basically what we need to do, we need to make this dynamic so that the color changes depending on the elevation. And unfortunately, we cannot do that with volume. So volume doesn't have native functionality to create dynamic colors for your markers. Therefore, we need to be a bit creative here and use Python core functionalities to do this. And when you think about dynamics, I think about functions. So basically, this loop is going through latitude, longitude, elevation, and then it passes those 3 values into this expression in here. However, color is being passed as a string always. But how do I change it depending on the elevation, for instance? Well, the way to do that is by creating a function that gets as input elevation, and then it does some actions inside the function, then it returns a color depending on the elevation value. So you can say, if elevation is less than this, give me green color. a green string here, and so on and so forth. So to give you an idea, the way this would work is, let me write the function here. This would be a good place to do that before creating the map object. But always you need to create the function, because I will be calling the function in here, so you need to create the function before this expression, so from here and upwards. I'll be creating that in here. Let's call the function color producer. Let's keep it simple for a while, just to demonstrate you how this would work. So let's keep it very simple. Let's say return green, and if you change this to color producer, and don't forget the brackets. By passing brackets, that means you are calling the function. If you don't pass the brackets, that means you're just calling the function name and you are not executing the function. So I'll just keep it like that and go ahead and execute map1.py. Alright, reload and you'll get the same thing, right? Because what happens is that this thing in here, this function call, will be equal to whatever you return here. So the type of this object is actually a string. So it's exactly the green string. Therefore now you can add some conditionals here. Basically you need to pass an input here, so elevation. Let me write whatever variable you like. I'll write elevation, and here you need to pass L. So L for let lon L. So, let's say we have 62 rows in the data table, and for loop will go through the first row of the table. It will get elevation and it will pass it to this function call. So the function will pass L into elevation, and then you say here if elevation is less than 1,000, then you want to return green for elevations less than 1,000 meters. If elevation is between 1,000 meters, so it's greater than 1,000 meters or less than, let's say, 3,000 meters, return orange. Else return red. So red will be returned if none of these conditionals is satisfied, which means elevation is neither less than 1,000 meters nor between 1,000 and 3,000 meters, which means what is left is greater than 3,000 meters. In that case, we will return red. For finding out those values, actually, you need to do a little bit of data exploration. For instance, you need to you may want to look at the data quickly like that to see what values you have, and then decide on the category thresholds. But you can also make more significant statistical analysis, like you can make a histogram and see the data distribution and then decide on these values. But let's keep things simple and let's decide on these values. Okay, I'll save this, check if everything is in place just quickly. Yeah, let me try the code. Go and reload. And yeah, we have some different colors here. Yeah, this is looking good. Let me double check the values. For instance, orange is between 1,000 meters and 3,000 meters, so we're doing good. Red is above 3,000 meters. Yeah, it seems it's working. Alright, I hope you solved the exercise, but don't worry if your map looks a bit different from mine. Anyway, here are my markers, circle markers actually, and I have green, orange, or red and orange markers. You get the idea, and they also have some sort of opacity. So I have set an opacity value of 0.7, which means 70% to them. As you see, you can see the marker that is underneath this one here. Anyway, here is the code. So let me explain what I changed from the original code. So I changed marker to circle marker. The location remains the same. Also pop-up attribute remains the same. And then I added a radius here of 6, which means 6 pixels. That's the size of those circle markers. Then I added a fill color. The fill color attribute is for the inner area of the circle. So you see this orange area, but you also have this outer color here, which I set to gray, and you do that with the color argument. So color equals to gray for all of the markers. The default color would be black, which I think is a bit heavy for the eye. Anyway, here is the fill opacity. For the transparency, I set it to 0.7, and that's it. I hope this is clear now, and I'll talk to you later. Hi, welcome again, and in this lecture, I'll show you how to add another layer to this map. Currently, we have 2 layers. We have the base map, which are map tiles by map box, you can see here. And the data are served by OpenStreetMap. And you also have your custom layer as well, which is a layer containing circle markers. So in GIS, Geographic Information Systems, these are referred to as layers. Now I'd like to add a 3rd layer to my map. That will be a polygon layer. So this current layer with markers, this can be referred to as a point layer. You also have line layers and polygon layers. So with points are better to represent locations, and you have lines. Lines are best for representing geographical features which resembles lines, such as roads and rivers. And then we have polygons. Polygons are best to represent areas. So for instance, in this lecture, what I'll show you is how to add a polygon layer that represents world population by country. So countries are represented as areas, and what we're going to do is each of the countries will have a specific color which will indicate the population of that country. So points for locations, lines for lines, and polygons for areas. Now, of course, you need to have some data to create a polygon layer. You know, just like as we did with markers, we had some data in CSV in text format, and then we use those data, we open them with pandas, and then we iterated through those lines of the data, and we added the markers to the map. Now, for polygons, the way to add polygons via volume is by using the volume.geojson method. So basically, let me make some space here. The way this would work is you want to add to feature group the variable here. You want to add a child, which will be a volume.geojson object. So this is the method with brackets here that creates a GeoJSON object. And for GeoJSON data, we will use this world.json file. You can find this attached in this lecture. Let me explain what this is, but careful, don't open it on an Atom, because if your computer is a bit slow, your Atom may crash. So try to open it with a lighter editor. such as Notepad, for instance, or cat on Linux terminal or Mac. Anyway, this is the JSON file. You can refer to it as JSON or GeoJSON. Actually, GeoJSON is a special case of JSON. Basically, the format is always the same. It starts with curly brackets. And basically, it contains a string which is like a Python dictionary with keys and values. Keys, key, and value. Where this curly bracket ends, somewhere here, I believe, if I'm not wrong. No, this one ends in here. Yeah. And then you have the other key, geometry. So what is geometry? Well, the type of geometry is multi-polygon. So basically you have these kind of attributes that describe the data. Type multi-polygon coordinates. So this is now starting to describe the features, the polygons. So these are the coordinates of the first polygon that will be displayed on the map. Let's say this is one specific country, and that's Antigua and Barbuda. Yeah, a small country, but anyway. And these are the coordinates that will determine the location of that polygon in your map. So basically, PathVolume will read all this information and it will decide where to put the polygons. And then you can also use other attributes of this, such as population, which is here. Yeah, you'll use this population value to put a color for that population. And so on and so forth. You have all countries of the world in this JSON file. So spend a few minutes looking at this file to understand its structure, and in the next lecture I'll go ahead and load the JSON file into Python and display the polygon layer. See you there. Great, in the previous lecture I showed you how a JSON file looks like, and in this lecture I'll go ahead and add that JSON file to the code. Remember, I provided you with the JSON file in the previous lecture. You could download it from the lecture resources. And so, this GeoJSON method gets a data attribute which is equal to the file object of the JSON data. So basically you need to create a Python file object which you can create with Open. Remember, Open is classic Python method for creating file objects. So there goes the path of the file. This happens to be in the same directory with my map1.py script, so I'm just passing world.json. And basically you're opening it in read mode, and yeah, I'll leave it like that for now. Save, execute. I think we'll get an error here. Yeah, we need to add an encoding parameter there, as suggested by the error message. So that goes inside the open method. Equals to UTF-8 sig. Save again, go and execute. Reload. And yep, we have the polygons displayed on the map. So that was quite easy to do. And something you should know is that you can also add points through GeoJSON. So in this case we added polygons, but that JSON file could also have lines or could also have points in its attributes. So, you know, this one we had an attribute that was stating these are multi-polygons, but this could be points or lines. And in that case, volume will display those features depending on this type attribute in here. Of course, you'd also have the coordinates attribute with the coordinates of the line, so the points where the line breaks and turn, and in the case of points, you'd have pairs of coordinates here. So I hope you get the idea. That was about this lecture. In the next lecture, I'll show you how to create a choropleth map, which is a map that uses coloring of areas to represent features. In this particular case, what we'll do is we will have these polygons with different colors to represent the population of the world for each country. We'll do that in the next lecture. See you. Hi again. In this lecture, I'll show you how to make a country by population map. I will be showing population of each country through graduated colors. So we'll think about a range of colors to represent population from low to high. And we have that piece of information in our wall.json file, which is stored in this pop 2005 attribute. So pop 2005 means population from 2005, which is quite old, but it shouldn't be a problem for educational purposes. So let's get back to the code. And the way to change the color of those polygons, because by default we have this green color, and there's also transparency on the polygons. You can see the base map on the background. And so to change that, you need to access the style function argument. But I have messed something here from the previous lecture, which could cause some problems later. This doesn't have to be in round brackets, so delete that. And one here as well. So we have 1, 2, 3 open brackets and 3 closing brackets. Now it should be fine. So we need to add another argument to GeoJSON. This is the first argument, so data is the first argument, which ends in here. So add there another style function argument, and you can actually break the line in here. You are free to break lines in Python when the expression is inside brackets, round brackets, square or curly brackets. So in this case, this expression is inside brackets, so we are able to break it, and it's good to break it at the comma. So style function equals to. Now this expects a lambda function. Lambda functions are just like functions, normal functions, but they are written in single lines of code. For instance, let's say L equals to lambda. This is a lambda function, x in power of 2. Oh, sorry, I had a typo there. Not lambda, but lambda. Okay, another typo. All right. So L is a function here, just like you'd have a normal function, and then you can call L. You can pass a value like 5, and that will return 5 in power of 2. So as you can see, you can write the function in one single line, and this can also be useful in other cases like this one in here that you'll see in just a bit. So lambda x. This also allows you to write anonymous functions. So this function now, it doesn't have a name. Like here, I assigned a name to this function because I needed to call it later. But this one here, we don't need to call it later, so you don't need to give a name. So here, the syntax would be correct if I do just like that. So let's go ahead and do this. Fill color with a capital C, lowercase f, uppercase C, and that should be in quotes. Let's say yellow, Now, if you want, you can leave it like that. So save the script. Exit the Python shell and execute the script. The execution went fine. Let me check the map, reload. And you'll see that the colors of the polygons changed to yellow. So that's how you can change the attributes of your JSON file. So to say, basically you add another, you add this attribute, which is not in the JSON file. If you search for it, you'll find nothing. And so now you can play around with this by adding conditionals inside this dictionary, such as if x properties pop 2005 is less than, let's say, 10 million. So 10, 1, 2, 3, 1, 2, 3. So what I'm doing here is I'm saying that set yellow to fill color if X represent the feature, a JSON feature here. So if the properties, actually if the pop 2005 attribute of this attribute, which is here, this is pop 2005. I know this is a bit complicated. Let me toggle software wrap. So now I have all the text wrapped here in the view, and here pop 2005 is actually part of this dictionary up to here. So this dictionary, these are a set of properties, and this dictionary is the value of this key, of the properties key. So what that means is that, we are accessing the value of the properties key using this syntax, which is known in Python. Meanwhile, X properties, what that is X here represents features. So you are accessing properties from features. And on the background, this is a bit of a black box. But Folium, what Folium will do is it will go through all the features of all the polygons, and it will check if the value of pop 2005 is less than 10 million, and if it is, then it will set this this color to fill color attribute. That's more or less about it. I think it's better to put this green, so if it's less than 10 million, put it green. Else orange if between 10 million. Do the same thing here. Properties. Actually, you can break the code in here. So properties pop 2005, and let's put here 20 million. So these are just arbitrary numbers. You can put everything that you want, but that will affect how your polygons are classified, are colored. So for population between 10 million and 20 million, we'll get orange colors. Else red. So everything above 10 million will be colored as red. Okay, let me save this, and I hope this will work. No errors. Reload. We have US colored in red because it has a population of higher than 20 million people, and yeah, this seems to be working fine. Yeah, Portugal has a population of around 12 or 15 million people, I'm not sure. So it's in the middle range of our classification algorithm. And yeah, that's more or less about it. And if you like, you can ask questions. And I'll be happy to help you. And I'll talk to you later. Thanks. Hi, and welcome again to yet another lecture on web mapping with Python and Folium. This is the map we built this far. And it contains a base layer, a polygon layer, and a marker layer. This is our code. Now, what I want to do in this lecture, I want to implement a feature that allows me to turn the custom layers on and off. With custom layers, I mean the polygon layer and the marker layer, because it's not possible to turn off the base map, at least as far as I know. And it wouldn't make sense to turn off the base layer. You don't want a blank page. So let's see how to do that. The key feature here is layer control class of the Folium module, which can be added like this. You want to point to the map object and then you want to add a child, so layer control is added as a child. So Folium layer control. Now, this will not work, but I still want to execute this so that you don't make this mistake later on. So let me reload the page. You only see the base map here, no layers at all. The reason this doesn't work is that when you added layer control to the map, you still hadn't added the feature group, which is an object that contains the JSON layer and the marker layer. So basically layer control will be looking for the feature group added to the map, but it doesn't find it at this point. Therefore, things are messed up. So it's important to put that after you have added the feature group layer to the map, right here. Save and execute again. Reload the map and you see the layers there, and you see this box here. So map box bright, this is about the base map and you cannot turn this off. And you also have this my map item here of the layer control panel. So this is the layer control panel, and you can turn on and off this layer. But as you see, this is turning off and on both the polygon and the point layer at the same time, which is something you don't want. So we go ahead and change that, and I'll explain why this happens. So this is happening because, you know, layer control, what it does, it looks for objects added to map with add child, like here. So you have added a child, and you have added only one child to the map object. Therefore, layer control will consider that object as one single item of the layer control panel. But that feature group object, it contains the circle markers, but it also contains the GeoJSON layer. Therefore, you need to change your strategy here. So how can you do that? Well, there may be different ways. One way is to actually create a feature group for volcanoes. Let's call it AFGV. So you add AFGV here, and then you want another feature group. Let me copy this line, paste it here. You want another feature group for population. Let's call this population. Let's call this volcanoes, like that. Change the variable name, FGP here, okay, FGV there. Add another child, which has to be FGP for population. Yeah, now everything looks good. So let's see if layer control will be able to read these two feature groups now. Okay, go and reload. The map looks fine. Volcanoes, working well. Population, 2. So everything is working fine. This is the map. And yeah, if you were able to build this as I did, then good job. You can also choose not to use feature groups actually. So you could have added GeoJSON to the map directly. However, for this case, for volcanoes, where you are adding, you are executing the addChild method multiple times, in that case, you'd have one layer for every volcano. So you'd have added 62 children to your map object if you did map without feature group here. So that means in this control panel here, you'd have 62 entries, 62 layers, and that's not what you want. So feature group comes in handy in here. For volcanoes it is necessary, but for GeoJSON you could have used map here and everything would be fine. But for consistency it's good to add both to specific feature groups. Volcanoes here and population here. So this is the code, and I hope you enjoyed this program, and feel free to ask questions, and I'll talk to you later on. See you. And here we are with a brand new section, and as you may have realized, this is one of those hands-on sections, as you're going to build yet another real-world program. And I use this particular program every single day for my personal use, and I wouldn't go as far as to say this has changed my life, but I can certainly say that this program has multiplied my work productivity. And there's no magic there. It's a simple Python program, yet tricky, that runs on the background. And all it does is it doesn't let you browse certain distracting websites, such as Facebook or your email account, during your working hours. And the program is tested to work on Windows, Mac, and Linux. And the idea is that once you build this program, you pass to the program website links that you think are distracting. So you pass links as strings, and also the time that you're working on your computer. And the program will block these websites during these working hours. And in that way, you not only are much more productive, but this also reduces stress, as distraction is also known to cause stress. If you don't have any problem with distractions like I do, you probably won't need this program. So yeah, I don't want to go further with the usability aspect. So usability is one of the benefits that you get from this program. The second benefit is, of course, the Python part, because this program is quite tricky to build, even though it's less than 30 lines of code. Here we're focusing on file manipulation and working with dates and times, and also the aspect of running a Python program as a process in the background, which is something we haven't yet learned in the course. And yeah, I'll do a quick demo now of the program. This is a program, so it's a Python script, a .py script, which later, if you want, you can attach to a graphical user interface if you want to give it to other people who don't know Python. And this Python script runs as soon as your computer starts. So now this program, this Python script, is actually running as a process. As you can see, this is a program running, and you also see that this occupies very little space actually. For instance, if you compare this with other processes like Chrome, like the browser, you see that this is very insignificant, which means that you can have the program run continuously on your computer and it will not cause any problem. So the program is running, and if you try now to access Facebook, for instance, you'll get this. This site cannot be reached. Same for Hotmail, so I have a Hotmail account, so I have blocked that too. That means I have to go back to work, making up my mind that it's not the time to spend on such things right now. Maybe after 6 o'clock I can browse those websites if I want. And yeah, that's about it. I know you probably have not much idea on how to start with this, and I understand you, but I'll explain the architecture of the program in the next lecture, and then start building it. So see you in the next lecture. So how do we go about blocking websites with Python? Well, Windows, Mac or Linux, they have a hosts file, which is something like this. So this is the host file, and if you open this host file, you'll see some lines there. And what this host file is for is that if you want to block certain websites, such as Facebook or this Mail Live here, what you do is you type them here, as I have done here. I have typed them via Python in this case, but you can also type them manually, but in that case you don't have control on the times when you want them to be here. So if you have a look at this, this is saying that the IP address should be placed in the first column, followed by the corresponding host name, which means this is a redirect IP address and this is a host name, which underlies that if you want to block Facebook, you want to redirect the browser to this IP address, which is a local IP address of your computer, which means when you try to access Facebook, you'll be redirected to that IP, and that shows this error web page. Good. Now this host file on Windows, it is located in this directory here. So Windows System 32 drivers ets, and then you have the host file, which doesn't have any extension, but you can open it as a text file in Atom or other text editors. On Linux or Mac, that host file path would be something like this and hosts. So very straightforward. This is both for Linux and Mac. And on Windows, that was this one here. So I'll copy that and just put it here. So that's for Mac and Linux and Windows. Good, now that we know how this host file works, we can open that as a file via Python using file handling methods, and we can add lines of text at certain times of the day in this host file. For instance, let's say I work between 8 AM and 4 PM. In that case, I'll write a Python script that runs the entire day and checks let's say every 5 minutes. It checks the time, and if it's past 4 PM, then it will delete these 2 lines. But if you are between 8 and 16, Python will add these 2 lines in this host file, and the host file will block access to these 2 websites. So that is starting to make sense, I believe. And all we need to start off is you have to think about, let's say, 2 websites that you want to block, or more, or just one, and also figure out where your host file is located, which I already showed you. And yeah, we should be good to go to start writing the program. And we'll do that in the next lecture. Okay, I think it's now time to code. And I'll be putting everything in one script. So let's call this website blocker.py. And yeah, again, the idea is that I'll be accessing this host file, which is in this directory. So if you are on Windows, you'll get it here. If you are on a Mac or Linux, that would be directly at this folder, and then you have the host file. So you get the idea. And so let's keep that path in a variable. let's say host path, and that would be equal to, I had copied this earlier, so I'm just pasting it here. And so on a Windows these are backslashes. On a Mac or Linux you'd have /, and then etc, and then you have of course the host's name, so the name of the file. If you're on a Windows you should be careful about something. These backslashes, sometimes you might have something like let's say n, a folder that starts with the n character. What that will do is Python will read this as a special character. And what this special character means is, it means a break line. So when you pass \n, Python thinks you're passing a Python keyword, and not actually a string. In that case, what you could do is you could pass the r prefix there, which means a row. That means, remove this, with this you tell Python that you're actually passing a row string in there. So you're not planning to pass any break lines in there like a \n. And yeah, I hope that is clear. Or alternatively, you can remove this and you can add 2 backslashes in each of these directory separators. So that would be an alternative solutions, but let's keep it like this. Good. And maybe 2 other variables, let's say redirect equals to this string. So the IP where your browse visit will be redirected when you browse Facebook or other things that you find distracting. And then let's say websites, so you need to pass the websites that you want to block. That could be a list. So I'm calling this website list, and here I'll pass www.facebook.com. And also you want to pass facebook.com as well, because sometimes these websites use 3 W's there for their domain, but sometimes they don't use. So you want to pass both these domains in the host file. And then maybe my Hotmail account. So how do I know that this is the domain? Well, if I typed hotmail.com and I can see that hotmail.com is sending me to this domain in the browser, so I can see this domain in the browser. When this opens up, my email displays. So this is what you want to pass there. You want to see the final landing domain, and maybe the other version. And yeah, we should be good to go. We have a list with 4 elements, and that means in the host file we will have 4 lines. I currently have these Facebooks here, so I'm gonna save the hosts again with all those, and I'll make sure I don't have any Python script running here in the processes. Yeah, I don't have any. Good. And I was afraid that I had a running script, a Python script there, so that's why I checked in the processes. So how are we gonna do this? Let me put this here and this here. Well, our goal is to have this file modified at let's say 8 AM. So at that time I want these 4 websites, these 4 lines to be added in here together with this IP. And then I want these 4 lines to be removed at let's say 4 PM. And there are maybe 2 ways to do this. One way would be to write a simple Python script that all it does is it opens this file, let's say with open host path as file, and then write these elements of the list in that file, in that host file, and that's all. And then what you do is you may use this task scheduler on Windows or cron on Linux, or other packages that do schedule tasks, and you may set this Python script to run in certain times. And that is one solution, but why would I use third-party tools when I know Python? I mean, I know Python better than these tools, and I'm not 100% sure that with these tools I'll do exactly what I'm after. But with Python is a programming language, so if you set to do something, if you think about something, that's almost 100% sure that you'll do that, because you have lots of flexibility with a programming language. So it's good that if you know a programming language, and then you should seek for a native solution. And yeah, that's what I'll do in this case. I'll not just write a simple script that adds to these 4 lines of code in this host file. Instead, I'll have this script running all the time. And to do that, I'll use a while loop. While true, and then everything goes inside this while loop. And what a while loop does is it executes an action very fast, so it depends on your processor speed. But in my case, for instance, what this will do, it will print out 1 every, let me guess, 1 millisecond. So it depends on your processor speed, but maybe faster than 1 millisecond. And let me open a command line and execute this script. Shift right click here, open command window here. This terminal plus package of Atom is having a problem at the moment. It has a bug, so I'll be using the simple command line. Terminal plus is probably more convenient, but this shouldn't be a problem. So Python, and the script name is website blocker. And here 1 is being printed out, as you see. Control C to interrupt the process. What I'm thinking about is to have some code here that checks the time every millisecond. So that would be something like, is time between 8 AM and 4 PM? If it is, then keep these lines in this host file. If it's not, then remove these lines from the host file. And that action would be performed every, I'm saying millisecond. But that's not a very smart thing to do. Why would you want your program to run every millisecond? That doesn't sound very memory efficient. So what we could do here is a simple trick. We import time, and then here we say time sleep, and let's say 5. And this time we execute this, and 1 will be printed every 5 seconds. So yeah, that's it. Which means if we right now the code that accesses these lines here, this host file, that code will run every 5 seconds and not every millisecond. So that's enough accuracy for us. That means that if time is 4 PM and then it goes 4 and 1 second, we will still have these lines here. We'll have this website blocked yet at 4 PM plus 1 second. So there will be a delay of 5 seconds, which is not a problem. And you can also put this higher number, so you can make it 5 minutes, which would be 300 seconds. But let me keep it 5. 5 is good. 5 seconds. And yeah, I think this is starting to make more sense for you now. And I'd like to stop here, and in the next lecture we will go ahead and write the code that writes these lines in this host file. Great, we have a while loop there that will make sure our script will run all the time, specifically every 5 seconds. Now inside this while loop we want to check the time, so we're talking about a conditional. When we're talking about conditionals, we think about if and else. So while true, which is always true, and that means the script runs all the time, if, and start thinking about how we can check if time is between this and that. Well, first of all, we need to import the datetime module. So we have the datetime class inside the datetime module, which would be, so the datetime class from the datetime module. So import datetime class, maybe as dt. So this will be assigned the dt namespace. I'm doing this because this expression will be quite long, so it's good to have a short name there instead of doing datetime.datetime.now and etc. Instead we do dt.now. So we want to check the current time against 8 AM and 4 PM. Now the current time would look something like, let me open a Python shell here, and from time import date time as dt, and dt.now. So this is current time, the year, month, day, hour, minutes, seconds, and milliseconds. Sorry, this is microseconds, not milliseconds. Now this current time is being generated automatically, and as you know, this is a spatial object, so it's not a string or a number, so it's a date time object. And what I'm trying to get here is that to compare this object against a date time that we pass manually, and you see what I mean with passing manually, we need to compare this date time object with a similar object. That would make sense. If you just pass, let's say, something like a tuple of 2016 and let's say 5 for month, 5 for day, and then 8, and then you compare this with let me call data.now. So let me compare this with this tuple 16 and 5, 8. You'll get an error. So what you have to do instead is you'd call date.now, so this object here, and then you create another object manually. So you call dt, which is the datetime class that we have imported earlier, just here, and then inside the bracket you pass the values. Let's say that, and let me pass 8, and this is saying false, so which means this value is not less than this. Let me check the time now again, and don't expect to get the same time as you did here, as you see. So now it's actually 9 p.m. and if you're wondering why, is that I had to interrupt the video, so I had to pause the video around this time, and then I went back like 12 hours later. So now it's actually 9 p.m. in here, and my computer was sleeping during this time. So that's just that, if you were wondering why. That means this time is not less than this, so it's not earlier than this. If you do, for instance, is it greater than this, then you get true. Now in our case we need to check actually against 2 date times, so that would be something like dt, and you would pass 8 here, so 8 a.m., and then here would be 16. So let's do that in our script instead of writing this in here. If we are here, so if dt, and now I could pass here 2016, and this would probably work for this year, but it's not very sustainable. So what you want to do is work with variables instead of values. What I'm trying to say is that instead of passing 2016 in there, you can have Python generate a year on the fly for you. So dt.now .year, and that would return 2016. Actually, we can try that here. now.year. Yeah, so this returns this value, which is a string. Type. Sorry, it's an integer. I meant to say an integer. So it's a number that the dt class reads it as the year. The year, and then dt.now again. The month should also be a variable. Month, and then dt.now day. The only thing that we want to have fixed is the time, so 8. What we're trying to do is check if dt.now is greater than 8. So if it is greater than 8, that means we are in the working hours. And also we want this to be less than 16. So what you do is you just copy these, and I forgot the bracket here. Yep. So you copy that, paste it here, a bracket there, and say 16. And then you have a column there for the if statement. So if this is true, then you want to execute your other statements. So let's write something more informative. Working hours. Yeah, let me execute this now. Python website blocker. We've got an invalid syntax. I think I messed up the brackets in here. This is okay, but this one should be inside brackets. Yeah, this closes in here. This one closes there, and this should be fine now. Let me try again. And unorderable types, this is comparing against a tuple. Sorry about that. It's actually not a good idea to copy and paste things. So as a general rule in programming, you shouldn't copy and paste things. You should write them, because when you copy and paste things, you're prone to making errors, like I did here. Now I'm doing copying and pasting here for the sake of video recording, so this is probably more convenient for you, as it saves you time watching me to write the things down. So it's better to use your logic and just write things so that you focus on what you're doing. And yeah, I think this error was good that it came up, because now you know that it's good to write things, to write the code instead of pasting it. So we have DT here that creates a datetime object. This also creates a datetime object, and this one as well. So let me go again, execute, and nothing is happening. So actually the code is running, but we don't have this print statement executed. The reason to that is that now it's 9 p.m. in here, so we are not within the working hours. And that brings us to the point that if I'm interrupting this, if you want to print something when you are not in the working hours, you'd want to add an else statement in here. So say else print fun hours. Save. And yeah, what we have this for is, while true, check for this condition and do this if that condition is true. So print out working hours. Otherwise, if this condition is not true, so if it is false, as it was when I just executed this script, then print this statement in here. And then sleep for 5 seconds, so don't execute the loop for 5 seconds, and then go again and check the current time again against these two values. So yeah, now we are in our fun hours. So every 5 seconds we get fun hours there printed out. Great. Yeah, I think we have the structure of our script, but we don't want to just print out these strings. What we want is we want to modify this file. So if it's between 8 and 4 p.m., we want to add those 2 lines in there. Otherwise, we want to make sure those 2 lines are not there in the file. So it's quite a bit tricky to access that file and add these lines and check if these lines are there. But we'll crack that in the next lectures. So, see you there. Good, I have the script running at the moment, and as you can see, the loop is doing its job, so it's printing out the working hours in the command line here every 5 seconds. And now it's 15 past 12, so that is between 8 a.m. and 4 p.m. Now we'll go ahead and add some lines here. So I'm thinking of keeping these statements here, these print statements, but also adding more lines here which correspond to file handling methods, which will access this hosts file and modify it depending on the time. Now, something that you should be aware about is this host file can only be modified by the administrator, which is if I run the Python program, I would have to open a command line to run the command line as administrator. So if you run on Linux or Mac, you do the same by using sudo. For instance, in this case, I open this command line by just right-clicking in here. So shift right-click and open command window here. But that will not run the command line as an administrator. So, which underlies that with this simple console, I cannot access this host file. So, in other words, you need to run your Python program with a command line or terminal where you have administrative rights. And for the sake of building the program, it's more wise to just copy this host file and just paste it here, where your script file is. The reason I'm doing that is because here I'll not have to open a command line as administrator every time I test my script. So once I make sure that the things are working well, then I just change the path. So at the moment I'll not work with this path. I'll work with this, let's say, hosts temp for temporary, and which is directly equal to the hosts file name, because hosts is just here in the same folder with website blocker.py. And besides making a working copy of this host file, you also want to make a backup copy of the host file, just in case you make some errors there in your Python code and you delete the file, or you just delete some content from your existing host file. And I'm just gonna copy this and just put it here, so paste it there in my D drive. And yeah, I'll just close the path of the real host file for now until I have a working script that modifies this host file successfully. This one here. Great. Now I can open this actually here on the right and close it here. Good, I think this is a good layout for you to see the code well. And yeah, what do we have to do now? Oh, well, we're checking the current time against these two other datetime values. And we have two scenarios. So in the first scenario, we are between these two times. And in that case, when we are between these two times, we want to make sure that we have 4 lines of text here in the host file, where each corresponds with each of these list items. Of course, together with the redirecting IP in the front. So the same format as you see here, but without the comment tag. And here we can go ahead and open this host file now with the open method and write the list items in the host file. However, we may also want to check first if these 4 lines already exist in the host file, because the host file can have 2 statuses. So the first status is the host file is without these 4 lines there, and the other status is the host file has these 4 lines. Therefore, you want to check for them. And to check these lines, you first need to read the host file in Python. So you want to apply a read method to your file, and then maybe add a loop that iterates through this list. And in each iteration, you apply a conditional that says, if a list item in content, where content is text you have read from the host file, so if that item is in the content, then don't do anything, otherwise add that item in the host file. So let's go ahead and do that with open hosts path. Sorry, that would be host temp, host path is a path that we'll be using later. So host temp, we want to open that file using, well, if we use the read method, so R, we could read the file content, but we wouldn't be able to write within this statement, within the with statement. And if you pass W, you wouldn't be able to read. The middle solution there is to use R+. With that, you'll be able to read and write. So sfile. And yeah, before writing anything, we want to first check there. So let's say content equals to file.read. And what content will contain is the entire text of the host file. And actually we could print that out just to see what we have this far. So normally you don't want to print that out, but in this case just for demonstration. And it's also good to check where we are this far. So Python website blocker, and so yeah, we got the text of the host file printed out. And before that, working hours was printed out, and now every 5 seconds the working hours and the content of the host file are being printed out. So I'll stop this. We're doing well. Now that we have the content, we want to iterate through the website list. So for website, in website list, for instance, the first item will be this one. So if facebook.com, if website, in content, so if this is in this content, in this text, and we are in the working hours in this part of the if conditional, so if Facebook is there already, we don't want to do anything, because that will already block our Facebook website. So we pass there, which means that Python will go ahead and check for other lines. So it will go here. So it says else will not be executed in this case because if was executed. So if that is not executed, then Python goes to the next line and it sleeps for 5 seconds. And then once it sleeps for 5 seconds, the loop starts over again and the condition is being evaluated again. Working hours is printed out if we are between these two times. And then we open the file again in the second iteration of the while loop. And we read the text and then we iterate in our list and check if any of our list items is in the text of the host file. And then we pass to the next lines if it is not there. And if it's there, we want to file.write. You do something like website, and yeah, we're almost there. We can check what we get this far so that you understand. So I executed this, and now you see that www.facebook.com was added in the host file, and then the next item of the list, facebook.com, and then my Hotmail account, and so on. So the 4 items of the list. Which means the structure of our code is working well. We just need to work a bit on the style, on the text formatting. And so we're printing out the website, but we also want the redirect IP in there. Actually, the first one should be redirect variable, this one. And then according to the host file style, we should have a space there. As you can see, it says the IP address and the host name should be separated by at least 1 space. And that's what we'll do. So redirect, what you can do here is +1 space within double quotes. And then we have plus website. And then to avoid the text being passed in one single line, you want to pass here the \n special character. That will create break lines between these text items. Great, now I can check this. Well, nothing will happen because Facebook is already there, so I'm just gonna stop this and delete this. And yeah, now it's working well. And by the way, if you have an antivirus in your system, you probably have some warning there because the host file is a bit sensitive. So your antivirus will be notifying you that some program is modifying your host file. If you want, you can just you can cancel this. Don't do any cleaning. You don't have to clean it because you know that you're the one who is accessing that host file. So cancel that. And yeah, it's working well, I believe. And we are done with the first part of the conditional. So now we are in this time, which is between these 2 hours. But if you were, let's say, 13 here, stop this, check again. In this case, we get printed out these fun hours, but the text in the host file will be still there. So what we want to do next is remove this text from the host file when this part of the conditional is satisfied. And we'll do that in the next lecture. So, see you there. Great. What we have so far is a script that checks if the current time is between these 2 times, and then it appends these 4 lines in the host's file. So we're talking about appending because this R+ mode there means that you can read and append text in your file. And you know that writing differs from appending in that when you write text in a file, you are writing the text in the empty version of the file. So with write, you'd have only these 4 lines in your host's file and not the other ones. Good, that makes sense. And yeah, that's the first part of our conditional. And if that happens to be false, then we want to execute something here. And that would be to delete these 4 lines. Now, as you know from the previous lectures of file handling in this course, there's no direct method to just pass some lines as arguments or as input and then have a delete function that removes those lines from a file. And that makes the situation a bit tricky. So our input here is this list with these names, with these items. Which means what we can do is, well, first logically you want to read this file and then check if these names are in here again, actually as we did in here, more or less. So let me start with that. With open hosts temp, that's a file path. And again here we are reading and appending at the same time. So we want to use R+ there as file. And let's store this text in a variable. Good. And yeah, this will load the text in our content variable as a single string. So that's probably not the best solution. So the best solution would be to use readlines instead, which will produce a list with all the lines in our host file. So for instance, this has 25 lines. We'll have a list with 25 items where each item represents a string with each of these lines. So for instance, this will be the first string of the list stored in the content variable. So content is now a list. Now that we have a list, we can start checking these items against the list that we have grabbed from the host file. So if these items are there, we want to delete them. But as I said, there is no direct way to delete these items. We have methods to write content, so we have methods to append content in that file, but not to delete. However, we can make use of the append method. We could start iterating through these items in the content list and check if Facebook is in that particular item. So in the item string, if Facebook is there, then we ignore that line. And if Facebook is not there, we write that line in the hosts file. So something like this. Let's say we iterate through this and say Facebook is not there. So create a host file, like a new host file, with this line there, and then go to the next line. If Facebook is not there, then append this line to that host file. So we'll have 2 lines and then 3 lines, and then we will remove the lines which contain Facebook. I know this sounds very confusing at the moment, but once I write the script and I explain line by line, I'm sure you'll have that moment where you say, aha. So you'll get that once I write the lines here. So we're here, we read the lines, but as you know, when you apply a read method there, like read lines or read, the pointer will be placed at the end, at the last line, so here. So we read the lines there, we have a list, and now we can say for line in content. So we start looping through the content list. And here I'll use any method. So we want to check these items against the lines of content. And that would be something like if not any website in line for website in website list. File.write, so append the line. So what I did here is, let me simplify that by talking about the first iteration only. So we have this line here, the first line, copyright, etc. And we are saying that if not any website, so any item, which is still a variable, in that line, so in this line. And so what is this website variable? Where the website is the first item of the website list, which would be this one here. But this will create a loop. So it will check the first item there and it will compare it so against the first line. So we are in the first loop and we say if not www.facebook.com in that first line there, then write that line in the file. Otherwise we wouldn't do anything. And so that would check the first item of the list, and that would go to the second item and check it against the first item of the host file, the first line of the host file, and then it will go to the third line and fourth line until this list is consumed. So that's for the first line of the host file. Then it goes to the second line and performs exactly the same thing. So it checks the 4 items of the website list again against the second line of the host's file. Yeah, I hope that makes sense. And yeah, I'll check what this does. But now it's 4:20. So we are in the working hours, and let me modify this. Let's say 16 to 17 are our working hours. So outside of this, we want to remove these 4 lines, which will be the case when I run the script now. Python website blocker run fun hours is executed, and 2 times. I'll interrupt this and check what we got. So we have this block here, we have this block here, and then the block is repeated. So it's not exactly what we want. and this ends, and then it repeats again, and it ends in here, and then it repeats another time. So the while loop ran 3 times. And the first block, so this one here, was the block that we had already in the host file. And then what happened is that we opened this host file in read and append mode, and then we iterated through the lines of the host file, and then we said append only those lines where there's no Facebook or this mail.live in those lines. And Python did just that, so it appended those lines under the existing content. And it did it 2 times. Yeah, so sorry, I said the loop ran 3 times earlier. Actually, the loop ran 2 times, but we had one existing block here. So the other 2 times, Python appended this block again. Great. Even though we are not there yet, I'm satisfied with the progress, because I think you are now able to understand how things are working. And now we need to put our logic into a very active state in order to make this work. So there are no new things that you need to apply here. It's just tricks. So you know about this truncate method, which what it does is it truncates, it deletes the content of the file from the current point and downwards. So for instance, if we apply that in here, what we would get is, so think about the first iteration only. So the first iteration will add the first block after the existing block, which is this one here. So this is the first block with all the Facebook things. And then the truncate method, what it would do, it will delete everything that is under this, which is not exactly what we want, because we would still have these things above. So we need to figure out a way to put this block of code above this, above the existing one. And to solve that is by using file.seek. So you know that when you apply a read method to your file, for instance here you apply the first read method, and the pointer will go here. So just after the last character of the file content. So when you apply a write method and append, you append lines, the lines will append after the pointer. Now, if you want to append these lines, as I said, if you want to append them before this existing block, you'd want to apply the seek method, so that you replace the pointer, just before the first character of the file content. What that will do is, it will get all these lines, so cut it from there, just to illustrate it, and it will place them in here. And then what the file truncate method will do is it will remove everything that is after that, and this as well. So we will end up with this text, which is what we want. Good. I hope I explained that well, and let me try that now. So I'll delete these and these, and this is the initial state of the hosts file. So we have these Facebook and Hotmail domains there. So I'll save this and the script as well, and I'll go ahead and execute. So it seems to be working well. Yeah. And if I change the hover, so let me, or I'll do a software wrap there. Okay, so that you see both the host file and the script. So now it's 3 to 4, and Let me put this 15, so we are in the working hours, and execute this, and the lines are there. Interrupt that, put this 16, and try again, and the lines are gone. Whew, so this is working. Again, just to wrap up, what we did here is, so we're talking about the else section, and we open the host file in a read and append method, and then we store the lines in a content list, and that puts the pointer in here, which means that everything you do after that will be applied under these lines. But by applying the seek method there, we tell Python to put the pointer in here, just here. And so then we iterate through this content list in this line and check that if any of these website list contents is in the current line of the content list. Actually, if it's not in the current line of the content list, then we write down that line in the hosts file. And then we truncate everything that goes under that line, which means we wrote all these 21 lines and everything that we had down here, so which was the previous existing hosts text, that content was truncated, so it was deleted from the file. And yes, we're basically done. I mean, we still have some things to make this work, to be able to run this script as a Python process on the background, because at the moment the way we run this is by opening a command line and then calling Python and then pointing to website blocker.py. And also we need to implement one thing. So at the moment we are accessing this fake host file, but what we want to do instead is access the actual hosts file, which is here. So hosts, and to do that you would first want to change host temp with host path. So host temp with host path. So where do we have host temp? Hosts, yeah, it's here. So host path there and here as well. Now that's about it, but if you try this, you'll get a permission error because you're running that as a normal user. What you want to do instead is run that as an administrator. On Linux or Mac, that is straightforward, so you'd want to say sudo and then Python and then point to website blocker.py. However, sudo doesn't work with Windows, and so the workaround here is to open the command line from the terminal and right click and go run as administrator. Yes, and then you'd have to cd for change directory and then /d, which means I'm going to the D drive. So when you switch drives from C to D, you want to use this \d, and that would be Dropbox. Block websites and demo. Then if I run the script now, Python and website blocker, now it runs normally. So we are during the fun hours. It's 16 past 6. Oh, so yeah, we are in the fun hours. And if you check the script, the hosts file, you'll see that you don't have any websites there being blocked. So let me try this. Let me change this to 19 so that we fall inside the working hours, and run the script again so we get working hours there. And if I go and check the notepad now, this is saying this file has been modified by another program, which is Python. And do you want to reload it? Yes. And yeah, we have these 4 lines there. If I try Facebook now, I won't be able to access it. But be aware though that sometimes if you have your browser opened and you just block Facebook or another website in your host file, the browser may not reflect it immediately, so it may take some time until the browser can get the information from the host file. If you want to speed up that process, you may want to restart your browser, so close it and open up again, and then check Facebook. And yeah, it should be the same for Hotmail as well. So it passes Hotmail, but then Hotmail, their servers redirect you to this website which I'm blocking, and you cannot access that either. So this is working well, we're doing great, and yeah, what's left now is to implement this program to run it in the background. So there's just a few minutes of video left for this section and we're done. So talk to you in the next lecture. As you were able to see in the previous lectures, our script is now running very smoothly. So what's left to be done there is to make this script run on the background as soon as the computer starts. Which means that the Python program, the script that we built, will run and it will check for the time and then it will do something depending on what time it is. But at the moment, the way we are running this is by opening a command line and then pointing to the script. That command line remains open as the script is running. So probably we don't want that, we don't want to have the terminal open there all the time as we do work in our computer. So a better solution would be to find a way to run the script on the background. And there exists a solution. It's just that the workaround is different on Windows and on a Mac and Linux. So this lecture is about making the final touch to the program so that we can make it work on Windows, to have the Python program run as a process in the background. So for Linux users and Mac users, you can safely skip this lecture and go to the next one where you can implement this script as a background process. So yeah, hello Windows user. I'm on Windows 7 here, but the solution should work on other versions of Windows as well. So how do we make a script run in the background as a process? Well, there's a simple trick you can do on Windows. You know, you have the installation of Python there. Let me go open file location. So when you're running a program, when you say Python and script.py, you're using this python.exe file, so which is an executable of the Python program. You use this program to run your file. Now, to run Python files on the background, you want to use python-w.exe, which is a specific subversion of Python for running Python scripts as a background. And there's a simple trick you can do. You want to change the extension to pyw. And once you do that, now you can go ahead. So here is the file, which extension I just changed. And what you can do now is just double click this to execute it. And there is no terminal shown, so the script should be running now. And you can verify that in the task manager. So this one here, which you can open, by the way. Right click in here and start task manager. And then go to processes, and then you should be looking for Python, for a process named Python here. And this time I expect this not to be here, so Python, yeah, Python is not here, so you should expect python-w.exe to be here. And the reason it's not there is that the script wasn't able to run because when you double click this, you are double clicking it as a user, not as an administrator. And if you're not executing it as an administrator, you're not being able to access this, to modify this host file, because as you know from the previous lectures, this is a protected file by Windows. But if you change this host file, let's change it to the host temp, which is this local file here, so the fake host file, where we don't need administrator rights to access it. Host temp. And now I go ahead and double click the Python file again, and now I should see python-w.exe in the processes. as you see here. So you don't really see any output printed out, but you can see maybe the results of this. So this is a host file which hasn't been added the domains in here because this says the working hours are between 4 and 7 p.m. Now it's 2:38. So let's change this to 8 and 16. Save the script and go and stop this process because this is running the old file and process. And now run again the file and check the host file, and now you should see these 4 lines which have been added in here. Great. Now let me stop this and process. And yeah, now we are able to run our Python file as a process in the background. Now let's go ahead and implement the scheduling part. So we want to run this program as soon as the computer starts. To do that, you want to go to Task Scheduler, just there, and then create a create task. Put a name for the task. I'm calling this website blocker, and configure for, I'm on a Windows 7, so I'm going to choose that. So Windows 7, and one important thing to do is you want to check this run with highest privileges, because if you don't do that, Windows will try to run the script from the normal user, so you want, in our case we need administrative rights. So check that and then go to triggers and then new. So begin the task. When do you want to run the program? Well, we want to run the program at startup. Well, they should be fine. Then go to actions and you want to create a new action. So what do you want to do? Well, we want to start a program. And normally you want to point to your program script, which is this one here, website blocker.pyw. Open that. Okay, conditions, and you may want to uncheck this option. You also want to run the Python program when you're on a battery on a laptop. And yeah, we should be good to go now. Press OK, and here is the website blocker task, which is ready to be run when the system starts up. So you may also want to disable it, but that's for another case. And yeah, now when you start your computer, the program should be running and your Python loop will run every 5 seconds, and the Python program will check the host file and so on. So you may want to test to restart your program now, or you can go here and test it by clicking run. Now the status is showing as running, and you may want to check if the task is really running or not. And it seems like it's not running. So python-w.exe is not here. And the worst thing is that we don't even get any error now because the task, the Python process is running on the background. And I know the reason why this is not running. You know, if you see in the script now, you'll notice that I'm still trying to modify the local host file, whose path is being passed in here as a relative path. So this is not an absolute path like this one here. And the problem with that is, you know, Windows is now executing this website blocker.pyw script, is executing it from another directory. So it's not executing this from the Dropbox pp blog website demo. Therefore, it cannot find a file with this path. Therefore, the solution to this is to actually pass the full path of the file here. Because as we are now, Python is not trying to find this host file, so it's probably throwing an error that says the host file does not exist. So let's go ahead and I'll copy this directory, put it there, and hosts, a backslash there, and pass the R prefix so that you can escape special characters. Save that, and yeah, now go to the task scheduler and end this and try to run again. So it says running now, and let's see. And yeah, now this is running. So python w.exe, and you can also check the host file. So the lines are there because it's between 8 and 4 p.m. So it's 4 to 3 of time. And yeah, the final thing we want to do is stop this very quickly and change this to the real path, host path, and this as well. Save it and go to the task scheduler and end the current task. So it's ready now, and run it again. Go to the processes. Python w.exe is there, so it's running. You may also want to check the host file, which is in my notepad, and it says the file has been modified. And yeah, I can see the lines there, the 4 websites that I want to block. And maybe you're wondering why this first line is there, so it should be separated in here and be there, but the reason this line was up here was because the cursor was set to this point before executing the Python script. So you may want to set the cursor, so let me delete this. You may want to set the cursor in here before starting the Python program, so before implementing this program. Now I saved it, and I now expect this file to be refreshed by Python again. So let me close that and open it again. And now, yeah, now this looks good. We have an empty line there, but that isn't a problem. So things will still work, even with Facebook in here like it was earlier. Things should also work, and everything looks to be working fine. I now cannot access Facebook between 8 AM and 4 PM. And that's all about it. In the next lecture I'm showing how to do the same. So how to run Python as a process in the background for Linux and Mac users. And that will end this section. So hope you enjoyed it, and I hope you make the most of this program for your use, your daily use. If something isn't working there, just drop me a question or a message, and yeah, I'll be happy to help you. Or even if you have questions regarding the script. So I know this has been lots of indentation here, and probably you get some errors there, and probably that error is because of indentation. So be careful with indenting your lines. And yeah, I'll close this now, and I'll see you in the next lecture then. Thanks. Alright, this should be the last lecture of this section, unless I add more lectures in the future upon student request. So I'm on an Ubuntu computer here, I'm not on a Windows, and so for Windows users you can skip this lecture if you want. If you like, you can follow this if you're curious on how a Unix-based computer looks like, such as Ubuntu. So this lecture is for those who have a Linux or a Mac computer, because in this lecture I'll show you how to make our Python program run when the computer starts. And for that we'll be using the cron service. Now cron is available both on Linux and Mac, so you don't have to install anything. Probably you know how to use cron already, but if you don't, there are just a few instructions that to make it work. And I'm gonna go ahead and open the website blogger.py, open terminal with right click and then Atom. So I'll be using Atom, which I have already installed earlier. And all we have to change from the script is the host path. So this was a Windows path, and on Mac and Linux that would be that one. And I'm gonna save the script here, go to the terminal, and I want to quickly check my host file. So I'm opening it with Nano. And yeah, this looks good. I have no websites there that I want to block. Ctrl X to exit. And yeah, what I'll do now is, before I try and add my Python script to be executed by Chrome, I'll go ahead and just quickly try the script with Python directly. Just a small change in here. Now it's 4:30, so let me change this to 17 so that we fall within the working hours. And I'll go ahead and sudo python 3 website blocker.py execute, and yeah, it seems to be working. It prints out the working hours, and yeah, interrupt that and go and check the host file. Yeah, the lines are there. Great, this seems to be working. Ctrl X to exit. So I hope things are going well on your Mac or your Linux as well. What's left to do now is to add this in the cron table. And to do that, you need to open the cron table file with cron tab with the E flag. Yep, and that opens the cron tab file. However, before you add any line here, note that the way we open cron tab, it opens up the file that is accessible by the normal user. So you may want to exit that and open a cron tab with sudo instead. The reason you want to do that is because we have to execute this website blocker.py script as an administrator, so with high privileges, because the host file is protected by Linux. So execute that and go at the end and say you shouldn't have this last line. I have this from another script, so ignore that, and I'll add another line here, reboot python 3. So you need to write reboot there, which tells Ubuntu to execute this command when the computer starts. So that would be home, my short name, applications, and website blocker.py. Yeah, that should do it. So that's the path to my Python file. And Ctrl X and Y and enter, and that should be saved now. So if you open cron tab without sudo, you'll see a different file. But if you open cron tab with sudo, you'll see the lines that we have just added. And yeah, before I close this lecture, just a quick tip. If you're trying, for instance, to point to your local host file, which you're passing as a relative path here. So for instance, I'm not passing this as an absolute path like I'm doing with this one here. So if you're using Python to modify a file with a relative path, and you pass that command in cron tab, as I did here, Python will not be able to access that relative path, because cron tab will execute Python from another directory which is different from where the website blocker.py is located. So it's good to work with absolute files. And yeah, now this should be working well, and if I restart my computer now, the video will be stopped, so I can't really record the rebooting process. But if you have some problems, just drop me a message or post a question in the discussion, and yeah, I'll be happy to help you as always. And if I browse Facebook, yeah, I'll not be able to connect, even though my internet connection is fine. So I hope that was helpful, and I hope you make use of this program. And I'll see you in the next lecture then.